Thank you. Um, it's an interesting title that we're using for this seminar, because typically what we would call a seminar like this is selected code updates. But I think that in our situation, there's a little bit broader view of things than just what a code update seminar would be. Skip and I, and I'm sure many of you, have sat through code update seminars that go through laboriously, section by section, everything that changed from the previous edition, 10% of which is interesting and 90% of which is sort of sounds bureaucratic. So we've tried to pick out a few of our favorites among that kind of 10% aspect of things here. There's also, for both of the presentations that we're going to do today, this first one that has some building and plumbing and mechanical, and the second one on electrical, there are handouts of these PowerPoint slides, and they're available at our website at codecheck.com/seminars, or you could also scan that QR code on your screen. And so I'm going to leave it up there for just a second longer so that we can give you an opportunity if you want to scan that QR code. The schedule, as I understand it, is that we're getting 4 hours of continuing education credits for this. And for those of you who have ICC certifications, this class is an approved course for an ICC preferred provider. In renewing your ICC certifications, you need to have at least 50% of your continuing education credits coming from a preferred provider, and we are. And so those course numbers are there on the left-hand side of your screen. It's 2 separate 2-hour credits. The other thing is I understand that there's now an agreement between ASHI and ICC, which may make this whole process easier, where each organization seems to have its own preferred flavor of educational credits, and that there's going to be some cross recognition between ICC and ASHI. I don't know the details of it, though. Okay, so with that, our schedule for today is going to be pretty simple. That we're start off talking for this next hour and a half, basically about, as I said, the 10% of code changes that interested us most. And then we'll take a short break, and then we'll talk about electrical to the end. Now, the electrical portion of this is going to be a longer historical overview of things than just what is applicable today, because there's some huge, momentous changes in the works for electrical systems. I want to also acknowledge some of the resources that we use in putting these things together. Publications from ICC, the International Residential Code, and also the book on deck construction by Glenn Matheson. We'll talk about that more, as well as guides to NEC changes from Ryan Jackson, which we'll also talk about when we get to that. So we would appreciate it if you would please participate. Please enter your questions that you have in the chat, and please let us know what when you have comment that you'd like to make. We'd like to hear it. I wish, and I'm sure I'm speaking for Skip as well, that we could be in the room there with you guys, because we much prefer doing things in person. So let's try the best we can to make this an in-person thing by having the participants who are just online also enter things into the chat there. So I'm going to start with a little bit of an overview of what I see having happened to building codes and standards since I've been studying these things, which is really only I've only been doing this, well, I guess for 50 years, haven't I? Okay, for a while. But there were really major changes that took place to the entire process of regulating buildings, in the between the way that it was done in the 20th century and the way that it's done now. And so what happened was that in the 20th century, building codes were basically written to be understood by engineers and the authorities who were responsible for enforcing them. They weren't meant to be understood readily by contractors or people who are not design professionals. That was one of the big problems that was identified with them, and that led to initially the creation of the CABO 1 and 2 family dwelling code. And what also historically has happened, and I find this especially in your part of the country, is that a great many houses in this country, I would say is possibly as high as 40%, were built without any building permits or inspections of any kind in the initial construction. And you guys who are out in the field seeing all this stuff probably don't find that hard to believe at all. So what changed in the last 25 years was they said, no, instead of handing people this big document that says you've got to go through all this engineering to decide how big a beam you need here, for instance, what the codes do now is they do the engineering for you. And they give you a table that you can look at, and you can figure out which correct line on the table you're supposed to be, and it'll tell you how big that beam is supposed to be. So that's what we mean by prescriptive, that they've done the engineering for you. The whole idea of the International Residential Code is that as long as you stay within its limits, you don't need to hire an engineer to design things, that they've done it for you. Another big change is that because the older codes didn't really have an intent of being just for residential or just for commercial, they dealt with fire protection issues on the principles of passive fire protection. That's to say that we're going to stop the spread of flame from one part of the building to the other. And that was much less so in residential. In residential, there was a lot of things, especially in the Southern Building Code, that were not allowed in the rest of the country. And today, the way these codes are written is as if there is going to be fire sprinklers in the building. The underlying premises of the code are a presumption that the new houses have fire sprinklers. Now, an example of that, where that might show up, is that it used to be, for instance, that we would talk about the separation between a garage and a house in terms of its time rating as a passive fire protection. Today, what it is they just say, man, put 1/2-inch drywall on it. And they don't give it an actual fire rating in doing so. The problem you run into there, of course, is that so many houses do not have fire sprinklers. And so what it means is that we should be looking as inspectors very carefully at the passive fire protection issues, things like the door between a house and a garage, or in some cases, say between your house and an accessory building, this kind of thing. Another major change that I've witnessed is that framing itself has become much lighter, that we don't use as much to hold our buildings up anymore. And in a sense, this is for energy conservation, that we'd rather fill our walls with insulation rather than studs that have a high thermal transfer. But correspondingly with that, the codes have become much pickier and much more specific about the strength of the connections holding that framing together, and particularly having to do with bracing for wind resistance. Another major thing, of course, is that houses are tighter, which in terms of energy conservation is mostly a good thing, but also creates indoor air quality problems. And then the next big thing I think that we're seeing is that we have such major changes in the energy codes and in the movement towards green building. You may have noticed in the news this last week that the state of New York has said that they will not allow gas hookups in residential construction that's less than 7 stories. That's part of a nationwide trend toward electrification of buildings rather than the burning of fossil fuels and contribution to greenhouse gases. So that's something that we see coming down the road that's going to be very significant and affects several of the things we're going to talk about today. So a little bit about our backgrounds. Skip Walker, well, I'll tell about myself and then Skip introduce himself, okay? My background is that I was a contractor, started building things in the 70s, and then started my home inspection business in 1980 and was a home inspector for 15 years, had some health issues and other things that really precluded me from crawling under houses anymore. And so I began teaching. I used to teach in a community college, and then I went to work for a building jurisdiction where I pretty much did everything. I did all kinds of inspections, but also plans review and particularly electrical plan review. And also I was very fortunate in 1998 or 1997 actually to make the acquaintance of Redwood Carden, the original founder of CodeCheck, and have worked with him ever since. And we've got about 40 different books we've collaborated on. And starting about 7 years ago, we were very happy to add Skip Walker to the team. So Skip, can you unmute yourself? And
yep, I just did. And as you can see from my I'm going to make sure here. Yeah, as you can see from my video, the books came in literally just before you went live, so they're unloaded and everything. So we now have CodeCheck Complete 3rd edition in stock. So anyway, a little bit about me. I'm in the San Francisco Bay Area, actually right by San Francisco Airport. Been a home inspector for about 20 years now. And early on, I took an interest in building codes, and as a way to kind of figure out how to pass my ICC certs, I started teaching, because the best way to learn something is to half-assed explain it to somebody else. I started teaching residential code classes at our local chapter meetings and kind of worked my way through the IRC front to back. And as I finished the building, I took the building certification. As I finished the plumbing, I took the plumbing, and subsequently ended up with, a combination residential, and I've gone on to add a California combo residential as well, which means I've taken the same 4 tests except California specific codes as opposed to the I codes. And in the process of doing all that stuff, I also ended up taken an interest in some things like decks and smoke alarms, life safety systems, and have done some talks at ASHI and Korea, our state organization chapter meetings, and publish a few articles. And somewhere about probably 7.5 years ago, Douglas walked up to me at a chapter meeting, and all he said was, "I need to talk to you outside." And I thought, what did I do to tick him off this time? And he said, "Would you be interested in helping on code check?" And I kind of did a double take, and I'm thinking, did I just hear him wrong? But anyway, so now I think about 6 books later, here we are, and um, we're the books are actually caught up pretty much to current codes around the U.S., and we're kind of rocking and rolling. So that's a little bit about me. I'm basically, though, I'm still an active home inspector. I do inspections. I did one yesterday. Do inspections all the time. And Douglas used to work this area, and you heard him mention crawl spaces. Predominantly, that's all we have here. We don't have basements. We have some slabs, but I call a slab a good day. Most of our construction is raised perimeter foundations, and meaning we're crawling a lot if you're a home inspector in California.
And you're being too modest, because Skip is actually has the greatest expertise about smoke alarms of anyone you'll ever talk to. So, and he'll get a chance to share some of that knowledge with you later today. So I want to still just do a few more preamble things here before we get to specifics. There are different types of inspectors in the different hats that people can wear and still be called a building inspector. Code enforcement inspectors are typically the people who can come by and say, hey, you can't leave your car up on blocks in your front yard for 6 months, and issue you a citation. But they also might issue citations for people doing work that would have required a building permit, and that has not obtained that permit. So that's what a code enforcement inspector is. Whereas a building inspector is somebody who actually is responding to the fact that there is a building permit and is out there to make their inspections during the course of construction. And then there's a home inspector. And a home inspector is really got a broader net in a way, because you can use a lot of the same data points as a jurisdictional building inspector or a code enforcement inspector, but actually much, much more, because you're there to provide your client with a range of a much wider range of information based on your own experience and training. So the way that construction projects are supposed to work, and they once in a while they do work this way, is that somebody decides that they want to build something, build a house, say. They apply for a permit, they submit plans, it goes through plan review, they issue the permit, you have inspections, the project is completed, and you issue a certificate of occupancy. That's sort of the on paper assumption that that would be the process. But then there's real life. And in real life, what happens is you start the project, and then you get turned into code enforcement by an angry neighbor who doesn't like the idea that you're building a second story on your house that's going to block the sunlight from theirs. And then you lie to the building department about what's new versus what was existing. And then you draw plans on a piece of scratch paper. My favorite plan that I ever received when I was a plans examiner was somebody tried to write one on a blue shop towel. When that doesn't just immediately result in you getting a permit, you complain that the building department is not homeowner friendly. It helps if you do this in front of the city council and mention the inspector or plans examiner by name. So after that, you eventually get your permit issued as an owner builder, where you say that you're exempt from having workers' comp insurance, because you're only going to hire people who are licensed and who have such insurance, when in fact you're going to pick them up in front of the big box store and try to tell them what to do. At that, you begin your war of attrition with the city inspectors. You eventually get the project signed off, although every city inspector can tell you that there's compromises that get made along the way. And then you sell the house. You're flipping it, of course, and you tell the home inspector while he's there that the city approved of everything, it's all perfect. And then when the home inspector disagrees with you, you tell the buyer that the home inspector is wrong about everything and that he's an idiot. So does this sort of sound like, is this a familiar tale? I'm sure we've all heard this one. Okay. So now that gets us to another, oops, got to go through this again here. Another issue is, what about home inspectors and codes? In a sense, I think that Virginia is lucky in that you don't actually specifically cite building codes in your reports, because there are times that I think you'd find the codes to be deficient. There's times that you'd find the codes to be irrelevant. But they're really, the purpose behind them is the same, that this is about safety primarily, and then durability, affordability, structural strength, etc. So this is the stated purpose of the International Residential Code. That's why we're doing it. Now, it's interesting. I found that Virginia does several modifications to the International Residential Code. First off, the version of it that you're currently using is based upon the 2018 International Residential Code, and you're going to change to the 2021 code in January. So one thing that does not require a building permit in Virginia is an accessory structure that's up to 256 square feet. Now, in the model code, in the IRC, that number is 200 square feet. In California, what is it, Skip? 120, isn't it?
Sorry, I had myself muted. Yeah, 120.
Yeah. So, but in Virginia, it's 256. Now, why do we care about, and when we're still looking at an accessory structure for any other things that have to do with safety or especially if it's got wiring or plumbing to it, we're looking at it like we'd look at any other building. Well, part of it is that there's a related permissive part of the code that says if you have, there's a basic rule that there's a certain fire resistance rating to exterior walls, that if there's no fire resistance rating to it, you've got to be at least 5 feet from another structure, but they exempt it for accessory structures. And so this would tell us at what point, at what size would this be something that should be held to a little bit higher standard in terms of its fire safety. Another requirement that you have, and this one really surprised me, is that for every door or window that is for the required ventilation of a building, they must have a screen. I'd never seen this before, but that's a Virginia amendment. This is a big one, that your rise and run of stairs is a lot steeper than it is in the model codes. And we'll look at a picture of this in a minute. Another one is the rule for child fall protection. Many of you have probably heard about the tragedy that happened for Eric Clapton's child when he walked over, he sort of toddled, he was a little toddler, and he went over to an openable window when they were in a hotel room and went through and fell to his death. And so the basic rule is that anytime a window can open up to something where the surface outside is more than 6 feet below that window sill, and the bottom of that windowsill is less than 2 feet above the floor, it requires child fall protection measures, and that would be bars or something that limited how far you could open the window. Virginia modifies that to say that it's okay until you get to within 18 inches of the floor rather than 2 feet. Another requirement is that you have a fire extinguisher in your kitchen if your building is not a sprinklered building. I found out the hard way why this is so important. When we moved into our house a little over 3 years ago, there were a couple of things. One, the home inspector told me that I should have photoelectric smoke alarms, and I thought, yeah, I'll get around to it someday. And then I didn't, the ones that I had were the ionization type. And then one day I was sitting here in my office and my wife screamed, and I go running out to the kitchen, and there was a big grease fire on the stove, and we kept a fire extinguisher in the kitchen, and I put out the fire immediately. And I was, we opened up the doors and windows to let the smoke out. And then about 5 minutes later, the smoke alarm went off. So Skip can talk more about that when he talks about smoke alarms. This is nerdy, this next one, no apologies here, but when I mentioned earlier that the codes have done all the engineering for you, and they do that in terms of how much bracing you have to have on a building for the wind zone that you're in. And the thing that the model code does is it says this all works if your house is basically could be described as several rectangular boxes placed next to each other, if that's what the footprint of your house is like. But it doesn't work if it's a V-shaped house. It doesn't work if it's got skewed rectangles, except in Virginia. They've done the engineering for you, and they do tell you how to do it, which is pretty remarkable. They really paid very close attention on that. Another thing that's a strange Virginia requirement, something that common sense would tell you need, is the drip edge on asphalt shingle roofs, except in Virginia. Virginia uses the IRC's energy code, which is really pretty extensive, and why we should be seeing nothing but LED lighting, that type of thing. Another nice amendment you have, and this is for any type of solid or any type of fuel burning appliance. When that appliance is replaced, it requires that the chimney or vent be inspected, and that if it's not inspected by the city, that the contractor who does it has to certify that he has inspected it and determined that the vent or chimney is safe. So that's even for replacing a water heater in the state of Virginia. And then one last one is that fire protection of floors isn't required. So how do we know all this about the Virginia codes? Oops, I should have made a QR code here. Basically, if you go and just do a search for Virginia residential code, where it will end up taking you is to the International Code Council's website, iccsafe.org, and you can look for free at the entire Virginia residential electrical code. If you want to copy it, print it, make notes on it, this kind of thing, you have to have what they call premium access, which is very expensive. I would assume that what most home inspectors do is you don't have a gigantic library of codes. You probably have our books instead. That's probably what I would be doing if I was a home inspector. So I mentioned this thing about steep stairs in Virginia. And so this is actually something that really surprises me, because that's what your code allows an 8¼ inch rise and only requires a 9-inch run. Whereas we compare that to what is in the model code, which is 7¾ inches and 10 inches. And you can see it's quite a difference in how steep it is to get up a flight of stairs. I would assume that this all got that way because the code for residential in your part of the world used to say this 8¼ and 9, and that they've just decided to stay with it rather than go along with what the new standard for it is. It's also, you can see, because a stairway that conforms to the IRC would have a lot more floor space that it's taking up, and that because it's going to be at least 15% more footprint within that building for that stair that conforms to the IRC. So I can see why architects and developers would push for an amendment like this. But what is really important to you as a home inspector? As a home inspector, what's more important, I think, than the actual pitch of the stairway is the uniformity of the stairs. And that, I know what I used to do as a home inspector is stand up here at the top and look down and try to see the line, the sight line of the nosings of the stairs. And if, as you're bending down to look at that, you see that there's one that's particularly off, then you might actually use something, whether it's, how high it is to the red spot on your socks, or holding your clipboard next to it and comparing it to the next stair and so forth. You might actually measure them, but I think that the main thing is just, are you aware of this lack of uniformity? The codes do say, and in the model code and Virginia, that that the tallest riser can't be more than 3/8 of an inch more than the shortest riser, and the deepest tread not more than 3/8 of an inch shallower than the shortest tread. So, or the longest tread, I mean. So the uniformity is what's important. And then, of course, the other places that you're most likely to find one of these to be off is either the bottom or the top, because of the change in the finished floors after the stair stringers had been built. Okay, another Virginia change is this one, that you don't require drip edge flashings for asphalt shingle roofs. Now, when I was a home inspector back in the 1980s, I used to see this routinely, where I would find that the last piece of sheathing at the eaves was damaged because of the water that sat there, particularly if you had more than one layer of roofing, the water that sat there at the edge, or that accumulated from the wet leaves in the rain gutter or whatever. And I would write it up, and I would say, hey, this roof should have a drip edge here, and you've got this damaged sheathing here as a result. And we would get a lot of pushback on it. And people would say, oh no, if the last piece is just kept, if you just keep the paint on it, you don't need this drip edge and blah, blah, blah. Well, finally, they put it in the codes. They put it in the codes about 20 years ago. I was really happy to see that they did. And unfortunately, it was in someone's interest to remove that from the Virginia code. So I mentioned earlier, you guys are lucky in a sense that you don't talk about codes per se, because I think most of you would agree that you're going to mention something like that to your client, that, hey, here's something that is likely to lead to some rot in their sheathing and is going to need repair. And just say it for that reason, not for the reason of, by the way, it doesn't conform to code. about 15 years ago, there were some horrific accidents that took place where a firefighter responded to a building and went into the building to put out the fire, and the fire had originated in a basement or a floor below and reached these manufactured eye joists, and the floor collapsed with a firefighter standing on top of it. So they lobbied to have this provision added to the codes. And basically what it says, and you have this a lot in Virginia, I think, that if you're standing in the basement, you're looking up at not trusses, but you're looking at manufactured eye joists, and you can see them. It would really behoove you to recommend to your client that they protect those with just with gypsum board or something like that. It is a requirement in other in the model codes, but Virginia did not adopt this section, which is kind of strange. Now, Skip, are these, how flammable are these eye joists, Skip? This type of processed lumber here?
So if you look at legacy construction, dimensional lumber, burn time to structural failure on that floor assembly, if that was 2x10s or 2x12s, would historically be in the 10 to 20 minute range. I think the average is like 15 to 17. What you've got right there, unprotected structural failure occurs in as little as 3.5, 4 minutes. So those eye joists are thinner, they're lighter, they span longer, they're flatter. They also burn like a dried out Christmas tree. And the same thing's true of anything that has actually OSB in it.
What happened with that one in Santa Clara that
Yeah, now I'm flaking on the name of it, but they had and I assume they're doing the same thing in Virginia as here. They're building a lot of residential four-story over an elevated slab called a podium. So you've got an elevated concrete structure and then 4 stories of light wood frame construction above that. A lot of that stuff is engineered lumber. So the one in Santa Clara, they actually were all framed out and they just put the scaffolding up to start putting the skin on the building. And they had a fire at one end. This thing was almost a city block long. A fire started like on the left end of the building. There were people in the building working. They ran to the other end of the building, and the fire was spreading so fast that if the scaffolding had not been there, they would have been forced to either burn to death or jump to their serious injury or death. It literally chased them that city block, and they barely outran it and got out of there. By the time the fire department got there, it was less than 10 minutes. The whole building was engulfed. All they could do was stand back and try to save the buildings around it. There was no saving the structure. It was a complete loss.
There was a Denny's restaurant across the street from that building,
Mm-hmm.
and it was across El Camino Real, which had 6 lanes plus parking and sidewalks and setback from the street. The windows in the Denny's restaurant, we're talking 100 feet away, melted. The window frames.
Yeah. That stuff burns very fast and very hot.
So at any rate, what we're preaching here is to say, even though your code doesn't require this, this is a construction standard that people should pay attention to. So even if it was a crawl space and there was a fuel burning appliance in there or anything that could be a source of ignition, you'd still want to do this. But Skip mentioned the magic numbers. If it was 2x10 dimensional or 2x12 dimensional, it would be have enough resistance. Okay. So I want to also just take a look at how Virginia amends their codes and what these look like if you do take the time to read them. That first off, anytime that there's a change, anytime there's a change in the model code from the previous edition, they put it in blue. So this is an example here that the model code says that it shall be discharged to the outdoors, and then they added that it cannot be, and that it has to be in accordance with this particular section, and that I think that's the one that requires a screen, and not to be exhausted into an attic or ridge. Then the part in red is what the Virginia amendment would be. And this one, by the way, is a really good example of something that where the codes got it right, where it says you can't take your bathroom exhaust and just run it over to a soffit vent or to your blocking. And here is an example of that, where you can see the little white corrugated hose there that's carrying the moist air to that spacer there that's keeping the insulation off of the out of the eave vent, and how it has basically caused all this mildew and mold on the roof sheathing there. Another example of how Virginia does this is, and this is where it gets a little tricky to read these sometimes, because there's a basic rule that say you've got a 2-family dwelling and you've got a forced air heating system in it. Well, you don't want to take the return air from one of those dwellings and push it into the other dwelling. Okay, maybe you got somebody on one side that smokes and the other side they don't. You know, this wouldn't be very polite. So that's a standard thing that's been in the codes forever. But there is a small exception you can see in red that Virginia makes to it, that says that if it's okay in a 2-family dwelling that does not have fire separation and that meets this other section that they mention here. And so you'd have to actually look at that other section to see what it is. The other section is saying if you have an accessory dwelling unit that's built within your existing house, you don't have to completely update the HVAC system return. So that's a good thing. So there was a small change that took place in the model code starting in the 2015 IRC. And that small change was just a few words that said that smoke alarms shall comply with NFPA 72. So, like, you know, there's some things that might be small, but that have a lot of impact. You know, hand grenades are small. So this particular rule is something that, well, I think I should hand this off to you, Skip, since this is your wheelhouse here.
Right. So NFPA 72 is the National Fire Protection Association, same people that do the electric code, fuel gas code and whatnot. It's their requirements for essentially life safety systems, smoke alarms, also deals with any kind of annunciator systems like fire alarm, pole boxes and things like that are in there, but residential is in there, and there's an extensive list of requirements. So as Douglas said, that one small change, where before in the IRC, there was like a couple paragraphs that says you put smoke alarms in these locations. Well, what they did when they put those words in there is they then effectively added all the NFPA requirements into the residential code. It's termed incorporated by reference. So I've got this one list, and then everything else comes from NFPA 72. So the general rules are going to be bedrooms, 1 per level, but then you start getting into this whole laundry list of other things that are all really important. You don't want smoke alarms within 3 feet of a supply return register. You don't want them within 3 feet of, and this includes carbon monoxide, of a bathroom if it's got a tub or a shower because of the steam. You don't want them within 3 feet of the blades on a paddle fan. the other things that come into play, and part of this has been incorporated into the latest IRC, is nuisance tripping sources, also known as ranges and cooktops. You want the alarms. Can you go back one, Douglas? Yeah, thanks. So you see 10 feet from the range. You can actually go down to 6 feet if it's a photoelectric alarm. So between 6 and 10 feet, it's supposed to be, the code actually says now, photoelectric. And the reason for that is photoelectric alarms are far less prone to nuisance tripping than ionization alarms. And then the other big change that's occurred is the fact that if you've got a fireplace in a sleeping room, so lower left-hand corner, and it could even be the fireplace is in the master or primary bathroom rather, and it's open to the primary bedroom, then you have to have its own carbon monoxide alarm in there as well. So if you go to the next slide now, we've got a whole list of things. So the 10-foot rule, if a smoke alarm is within 10 to 20 feet of the cooking appliance, it can be an ionization alarm as long as it has a hush button. It's still going to nuisance trip because that's just what they do. The photoelectric is also allowed. Anything over 20 feet can be either one, although I can tell you from personal experience, the ions that we used to have in our house were way further than 20 feet away from our kitchen. And anytime we did any kind of broiling, that alarm would go off in a heartbeat. So let's see what else. Distances, yeah. So I think Ruben talked a little bit about the minimum 4 inches from a ceiling, max 12 inches. Within 4 feet of the no more than 4 feet 4 inches rather of the peak, max 36 inches out from the slope ceiling. So they have to be up near the top, and that's because smoke, when it goes into a room, it rises and then it builds and moves down. So you want the smoke to hit the alarm first. There's also in NFPA 72, there's some rules about putting smoke alarms on ceilings or walls that get hot. So if you've got an uninsulated attic, like in an older home, and it has the potential to get very warm, then you're actually not supposed to put the smoke alarms on the ceiling. And that's because smoke alarms and carbon monoxide alarms have a temperature operating range, typically in the low 100-degree range down to about 40. So a garage that gets cold in the winter, a ceiling that gets really hot in the summer, those alarms won't work. I can tell you from personal experience that when I used to do the kind of the road show stuff, I did one up in Seattle for Western Washington ASHI, and it was December, and we ran a photoelectric ionization test with a fish tank out in the parking lot of some hotel. And we couldn't get the alarms to go off because it was like 30-something degrees out there and nothing went off. So they actually really do have a temperature operating range.
Good, good. All right. CSST. This picture was taken in Virginia about 20 years ago when this first became a popular item. And what we have is a medium pressure system over there on the coming in from the right, and then an MP regulator that gets this down to the typical 1/2 PSIG pressure that each individual line goes to. I think this is a really cool idea to have manifolds like this, rather than having a series gas system where you have to have a larger pipes at the source and progressively smaller down to the utilization. But we have since then heard a lot of stuff about CSST. So we in general what I think home inspectors say, and I know certainly what some of the state laws say, is that home inspectors are required to report as a defect any yellow CSST that is not properly bonded. Well, Skip, has anybody ever made a CSST that was a different color that did not have an arc resistant jacket? No answer.
Sorry,
Okay.
I muted myself.
Yeah.
I've actually got pictures of some black CSST that does not appear to have any arc resistance. When they said yellow, my first thought was somebody's going to figure out that if they just make the jacket black, that they can skirt the rule. And sure enough, they did. I got a picture from Colorado and another one from actually Central California, and neither one of them, they look like some kind of bootleg
Hmm.
nonsense. So yeah.
Typical. Now, when CSST first came along, what happened was it was only available from plumbing supply houses. You couldn't just go into the big box store and buy it. Part of the ANSI, American National Standards Institute, part of the standard for CSST says that whoever installs it has to have completed a training program and be qualified to do so. Once they started putting it in the big box store, the training requirements were just one more of those pieces of paper in the package that said it'd be really nice if you could go to such and such place and take a website and take this test. The next thing is, what is the big concern with CSST? And we oftentimes use a shorthand method of describing it to say that it's because of its vulnerability to damage in a lightning strike, but there's a word left out there. It should be its vulnerability in an indirect lightning strike. If you have if your house is directly hit by lightning and you don't have some type of a passive lightning protection system, a Franklin system or something, then all of this is irrelevant. Lightning is going to go where it wants to go. It's going to go through your wiring. It's going to go through your gas piping. It's going to go through your CSST, bonded or not, and so forth, or arc resistant or not. But if it's an indirect lightning strike, which is the more common thing, say it's a block away from you, it's elevating the voltage of everything that is connected to Earth, and that voltage, if it is a high enough voltage, will jump to adjacent conductive surfaces such as the CSST. So the stories from which this originally originated, the houses in Texas that burned down and were successful in pressing a lawsuit against the CSST manufacturers, have given rise to this requirement that the CSST be bonded in such a manner as to minimize the potential of voltage between the CSST and an adjacent grounded metal system, such as maybe the sheet metal in your chimney from your furnace or something like that. So that's the origin of this. I'm curious if anybody could put it in the chat, if you have personal experience with damage from to CSST from a lightning strike or some other similar problem like that. If anyone does, please say so in the chat and let the rest of us know.
There was one case and I think I read about this a couple of years ago, where somebody had a dryer that was fed by a CSST, and it was exposed, and it was in contact with the metal dryer vent transition duct, and somehow or another shorted out and burned a hole in the CSST. And they knew this because when the dryer, fortunately, the dryer was running when this happened. There was a blowtorch coming out the back of the house at the dryer vent. So they had the wherewithal to turn the gas off and then turn the power off.
Wow.
So if that had not happened, if they'd had the gas leak and then they turned it on, it would have like blown the place up.
Right. So another thing about CSST is that even though we look at it and think that it's about the same size as a regular pipe or tube, it's not. It's essentially one size smaller. And so the way that it's sized is different for each manufacturer, but you have to look at a chart to see how large a piece, what diameter you need. So the codes basically talk about CSST in the plumbing section of the IRC and in the international and uniform plumbing codes and mechanical codes and so forth, and the international fuel gas codes and NFPA 54, the national fuel gas code, all those different codes, all basically that are plumbing and mechanical and fuel gas codes talk about CSST and these requirements for bonding, and they all say exactly the same thing. Is one of those things in terms of code development that basically whatever NFPA 54 does, everybody else copies. So one of the things is this requirement for bonding of the yellow jacketed CSST. And I was looking around, I didn't take me too long to find a picture of something.
Douglas, Douglas, can we interrupt for a minute?
Sure.
Alex has a question for you.
Yes.
There is black jacketed CSST, and you may be getting into this even as I'm looking at the picture on the slide,
yeah,
that is considered to be as a non-CSST. It doesn't need to be bonded. And so, that's something that I think I was reading here with the NFPA 54, the use of arc-resistant black jacketed CSST has been approved, and it allows it to be treated as a non-CSST type pipe.
Right, that's correct. We'll get there. We'll get there on that.
Yeah, the point I was trying to make earlier is that there's people out there that are making what amounts to yellow CSST, except they're putting a black jacket on it. There's no arc resistance to it. So when they wrote the language that you guys have to put in your reports, which is the same thing that they passed in California, and I have to do the same thing, they used yellow and black. And that's a mistake. I mean, in my opinion, because it allows somebody to go in and put black jacket on what would otherwise be yellow CSST, and for whatever reason say it doesn't have to be bonded.
Yeah.
Sorry.
Okay, good. So anyway, this is just an example I found. It didn't take long looking on the web. And I stole this from Ben Hendrick's website. He's an inspector in Kentucky. He's always got interesting stuff of somebody that did not understand this at all. So there are people out there who again, do not get it about bonding. And putting that clamp on that CSST is just going to crush it and make it likely to leak. And of course, the clamp should have been on the hard pipe or on the fitting, and of course, it shouldn't have the two conductors under it like that. So this is typical of what is bad out there. People don't seem to understand that even though it's got this yellow jacket, that it's a continuous metal path inside those to those fittings, and that is your fault current path. So here's the Virginia amendment to this, saying that basically what Virginia has done here is they have taken the next code cycle that you guys haven't adopted as your model code yet and incorporated it into this cycle, which is a good thing. that they're very current with this. And what they're saying is that basically, as our other person was just saying a minute ago, that that if it has to have this arc resistant jacket, or it has to have this bonding. Recent changes to this are saying, for instance, that the bonding jumper has to be not smaller than 6-gauge copper wire, and can't be longer than 75 feet. If it is going to be more than 75 feet between the CSST and the grounding electrode, and you install a supplemental grounding electrode, you have to run a bonding jumper back to it, and between the two electrodes, and so forth. So the in the model code, current model code, they're saying that this applies to that they've got a separate section here for the arc resistant jacketed CSST. Now, as far as I can tell, what this arc resistant jacketing is about is basically just, it's almost like it's holding it together in case something wants to deform inside there. I don't quite get it as to what makes this so special as compared to regular yellow jacketed CSST, except that it has successfully taken over the market this way. So I'm going to give them credit for something there. But I also find it very interesting that this is primarily stuff that's in the plumbing code. And so I have this slide here that has the complete NEC text on CSST, which, as you'll see, is nothing. So here's the thing, is that the National Electrical Code says you cannot use gas piping as your grounding electrode system. The primary purpose we have of a grounding electrode system is to keep everything in the building at the same voltage potential as every grounded surface in the building at the same voltage potential as the earth. We'll call it 0 volts as a reference, even though it's oftentimes more. But we don't use, we use underground metal water piping, we use foundation steel, we use ground rods, we use ground rings, all these other things to create the metal in the earth that is keeping our building at that low potential. We don't use the gas piping for several reasons. First off, underground gas piping is mostly plastic, and the wouldn't be a good path. But secondly, the only bonding that the NEC requires for gas piping is as an equipment bonding conductor. That is to say, if I have an electrical fault and I now have 120 volts on my gas piping, I want it to complete a circuit so that a breaker trips. And and that's all I need is for it to be able to trip the breaker. So if I've got a 15 amp circuit to a furnace, and that furnace has an equipment grounding conductor that's just a 14 gauge copper wire, and that's what my gas is connected to, that you don't need any further bonding of your gas pipe because it has the effective fault current path. So a little history on this. In the run-up to the 2011 National Electrical Code, the CSST manufacturers asked the Code Making Panel 5, the one that is in charge of grounding and bonding in the NEC, to include a requirement for bonding CSST. And the people on Code Making Panel 5 said, what on earth for? We've already got a bonding requirement for the effective fault current path. And the people who are manufacturing CSST said, no, we need this for lightning strikes. And the response, basically, the less polite version of it, of what the NEC code panel said to them was, well, if your product is that bad, why don't you take it off the market? So this is why it's not in the National Electrical Code. Now, so the conundrum here is, It's in the plumbing code. It's something that plumbers are supposed to be trained for. It's what we end up doing as inspectors and home inspectors, oftentimes by law we're required to do, is to say, you should have an electrician look at this. But there is nothing in the training of an electrician to tell them anything about CSST, and there's nothing to go by in the National Electrical Code. So I don't think we've heard the last chapter in this one. I think there's going to be more to come.
The one thing I'd kind of jump in really quick on that is the law that you guys have in Virginia, and I know Texas does, California does, I want to say Florida and a couple other states, that was pushed by two organizations. One is the manufacturers of CSST, and the other was, as I understand it, one of the largest law firms in the United States. And I talked to an ASHI guy who was fighting this in Texas, and he said what it really comes down to is they want the home inspectors E&O insurance if the house blows up. So just cross your T's and dot your I's is all I'm saying.
Yeah. All right. The model code exempts decks that are less than 200 square feet. Virginia's code doesn't. I think Virginia's code covers all decks. There used to be that when we look at a deck, this was the best reference guide that we could find, this design for code acceptance from the American Wood Council. They're not going to keep this up anymore, because what we have now is that what's in the code itself is far more comprehensive, and so DCA 6 is kind of a vestigial document at this stage. And there's also this excellent book that was written by Glenn Matheson, that is everything you need to know about decks and much more. So this book, if you don't own any code books yourself, this book still is the one book you should own. Wait, Skip, did I say that? Didn't I say code check first? Anyway.
We'll talk about that later.
Yeah, because what will happen with what happens with this book is that it's he talks about, for instance, the stairs that lead to this deck. He talks about guardrails. He talks about the basic issues of egress and clearances from different things and so forth. A lot of other related things that might come up if somebody decides to put a deck in a particular spot, and he covers them. So it would really be, what would happen is this is almost like the life safety things that you need to know as a home inspector are in this book on decks for some reason, okay? And it's because Glenn is very comprehensive in his approach to this subject. Now, he is the representative from the North American Deck and Railing Association to the International Code Council. Many of the specific items that are in the code now and that have obviated the need for DCA 6 were actually proposals that came from Glenn. So I can't speak highly enough of this book. And also, if you want to buy this book, you can get it from the International Code Council, but you can also buy it directly from him at deckcodes.com. So I strongly recommend this. Now, a whole lot of things changed in this latest code cycle, the one that you guys will be using in 2024, and that his book is based on, that they updated all these tables essentially to take into account snow loads and a few other things. There's, like I say, now we've got a 50, 60, and 70 pound snow load table for it. Some things did remain the same. For instance, the ledger connections, which we'll get to. Most deck failures are failures of the ledger. Just some overall rules. Again, this isn't necessarily changes, but that your flashings are corrosion resistance, your fasteners and connectors corrosion resistance, wood pressure treated or naturally durable. So no southern pine decks unless it's pressure treated southern pine. If it's a plastic deck or a manufactured deck railing system, there should be an ICC evaluation report for it. Okay, so the previous code had a simple table for post heights. The new code depends on the tributary area. There's a sort of statutory limit that can't ever be more than 14 feet to be within that code. That's not to say you couldn't have a post taller than 14 feet, but you'd have to have it engineered. So here's some examples of right and wrong on ledgers. That basically the code specifies this bolting arrangement that we see here on the left. And what you guys see is somebody attempting to hold it by nails into brick veneer or into siding or into whatever. So these are the three basic designs that we see for how to attach a ledger to the house. And notice that in all of them, we're managing to catch the rim joist, or in some cases, they could catch the top plate of a wall below it or a sill plate. And the one thing I would say is I do see some drawings occasionally on this detail C here, where it's showing spacers between the ledger and the siding. In some details I've seen, the water resistant barrier might continue all the way through here. But I do think it's better to do it this way, where we have it lapping over the flashing that goes over the ledger. Okay, so just I guess Ruben talked to you guys today about a lot of, showed you a lot of good things on decks. So I think this one is this one's interesting to me, and that it's just, aside from how ugly it is, how it seems like it's sort of homeowner engineered in a way, and that they've got this awful kicker here that they're trying to use for lateral restraint, since they don't have it actually attached to the house and they can't put a hold down device there. Something that's new in this code cycle is these notches on the guard posts here are not allowed. You can't do that. That's a specific code violation. And then also, because what will happen is that as you push out on that, even if those bolts stay in place, you're going to split the post. Handrails too small or too large. I'm going to skip this. This is a small change in the code that's coming up, which is that the old code for guards was this 200-pound load in all directions, and now it's 200 pounds applied at the top in an outward or downward direction. When people talk about this requirement, this load requirement for a guard, people, I've seen this repeatedly, or home inspectors saying, gee, this looks funny to me. How could it ever be tested to see if it works can hold a 200-pound load? You got to remember that this 200-pound load is not a deflection limit. It is 200 pounds to failure. Okay, so failure, in other words, is it going to break if somebody 200 pounds leans against it? Okay, and what that means is, since it's not a deflection limit, if you look at what some of the ICC approved systems are, you can push out on that top rail. I've seen ones that you could push out as much as 6 inches, and it still meets the 200-pound requirement. It just bent, it didn't break. So the other other thing that, the thing that bothers me is we've probably all seen the decks with wire as the infill, horizontal wires as the infill. It's the same thing there. They might be limiting the space to not more than 4 inches until somebody deflects one of those wires, and then you can push it and have a much larger opening. So, okay. So this whole section on guards is new in the 2021 IRC. It's discussed very well in Glenn's book and discusses all these different ways of attaching them and so forth. So I'm going to mute myself for a second here, but because Skip is going to try to explain why we have a circle around that particular balcony there. Where is this, Skip?
This is in Berkeley, California, which is right across the bay from me. I was going to say one other thing on decks real quick before we move on from that. If you guys don't do anything else, there's 3 points of failure that are the most common in decks. Basically 100% of deck failures occur at the ledger, at the guardrails, and at the stair stringer to the deck or landing connection. So 90% of deck failures occur at the ledger. The other 10% is split between guardrails. In other words, all the drunk people out on the deck leaning, and they take it over, and the stair stringer connection to the deck, which Ruben got into a little bit today. So if you really hone in on those 3 places and really nail them, you're going to eliminate almost 100% of deck failures. It's really, I can't emphasize that enough. So to this case here, this
So
was...
Skip, let me interrupt for just 1 second. Skip. You had a problem with your audio a second ago. Could you list those 3 again?
Okay, all right, sorry. And thanks for letting me know. So the 3 points of failure on decks is typically 90% of deck failures will occur at the ledger connection to the house. That's 90%. So 9 out of 10 deck failures are going to be ledger related. Almost all of those are going to be nailed connections. I'd say a disproportionate number of them will be nailed connections that pulled out. The other 10% of the failures occur at the guardrails and the stair stringer connection to the deck. So my point being is you can eliminate almost 100% of deck failures if you simply focus on those 3 red flag areas. Really, really super critical. To Berkeley. So this is a 4-story light wood frame construction over a podium. Very typical construction around here, and I assume the rest of the US as well. And what you're looking at is a unit that was unit 405. And this building was given its certificate of occupancy in January of 2007. So new construction. In June or July, I can't remember now, of 2015. So 8 years and some change later, you had 6 Irish kids dead on the street. Another one turned into a paraplegic. He recently passed away. So there were actually 7 fatalities and another couple people that were seriously injured. This is an 8-year-old balcony. So if you go to the next one, that's what was left of the wood. Now, this occurred during an epic drought in California. So the balcony certainly leaked, but there was very little rain during that lifespan that that balcony survived. Most of this damage was the result of anybody hazard a guess? I know I can't hear you, but if we could have a discussion if I was actually in the room. Stack effect. So warm air rises and pressurizes the upper floor. So that balcony was on the top floor on the leeward side of that building, which meant that the exterior was under a slight negative pressure when the wind blew, and it would actually suck air from the building as it pressurized the upper floors. It would suck it into that cavity, and then the moisture condensed out and rotted it out. And guess what? They didn't put any ventilation, zero. There was no ventilation on that thing at all. So anytime, and I know all this because I actually did expert witness on that. And I was the one that pointed out to them the fact that, you know, it doesn't have to leak to fail. It simply takes moisture condensing and time and a lack of ventilation. The argument was that the building code didn't say you needed ventilation, and it didn't say it in those words, but it did say that the exterior cladding, including balconies, had to resist water intrusion, prevent it, allow water to drain if it occurred, and to prevent condensation. And clearly, it didn't do any of those things. So 7 kids died. It was settled under a non-disclosure, but I think the settlement was somewhere north of $40 million. Everybody paid on that. The contractors, the waterproofing contractor, the architect, the building owner, the property management company, everybody paid on that, including the company that did the property condition assessment when that was purchased in 2008. So no one wants to own that problem. You don't have enough insurance for this kind of an issue. So just because what you're inspecting is a 2-story doesn't mean that that can't happen or is happening. I would say if you've got unventilated, enclosed, soffitted areas on cantilevered assemblies like elevated stairs or balconies or whatnot, it's teed up for something like this right now. If you go to the next one, I'd be looking at the bottom side of these things all the time. And did you want to take this, Douglas, or you want me to keep
Yeah,
going?
I want to kind of move ahead here. I didn't realize we're going very slow on our schedule.
Okay.
I'd like to get us into the electrical portion of it. And so I want to just ask Jim, should we be taking a break at all before we in this, or are we going to just go straight through, or how are we going to do this? I'll tell you what I would like to do is I'd like to go very fast through the rest of these slides and encourage you all to download the handout, okay? And then we'll take like a 5-minute break, and then we'll go to the electrical section of this. Something that I have seen in houses in Virginia is that a lot of times they are not bolted to their foundations, or that I've seen houses there with shot pins and things like that. And so since this is partly based on codes here, we're talking about this, that I want to just emphasize that all walls over foundations are supposed to be bolted to the foundation. Now, there are some exceptions, but there also are some interesting rules to this too, that the holes for the bolts shouldn't be more than a 1/16 of an inch bigger than the bolt. And I know what we used to do in the city where I worked, if they drilled the holes too large, we made them fill the annular space with epoxy afterwards, after they put the around between the bolt and the wood, so that it wouldn't slide. There is another thing. This is a picture taken in Virginia here on the left that I presume was probably this type of an MAB strap here. And instead of being properly installed through a hole drilled in the sill plate, they bent the straps back and tried to wrap them around it. When I took this, there was an entire subdivision of houses built this way. One other thing is these straps that are an alternative to bolting are intended to be slightly to bend them to fit in the field, but they're only allowed to be bent once. And a lot of times when people are building houses, they will bend them just to get them out of the way for working the concrete. And if you bend them back and forth a few times, they just break like anything else. Small code change is that they now, it used to be that the code was silent on this. The ACI 318, which is the basic manual for concrete, says that those bolts must be held in place with bolt holders so that they, and then you consolidate the concrete around them when you're filling the form. If you just punch the bolt into wet concrete, you're not likely to get it vertical. And if it's near the edge, you're going to have this kind of cracking. This crack is on a house that isn't even built yet. It's just at the foundation stage. And I always, when I look at this, I always remind myself all big cracks started as small cracks. I'm gonna just leave this for these other things for us to look at over on the handout. And I don't know why that one was there. And I think you can just read all this stuff yourself. It's easy enough. So why don't we take like a 5-minute break and come back and start with the electrical presentation. Is that okay? All right, let's continue. Everybody's back? Good. So same information about where this handout is located and about the course approvals there. All right, I'd like to also acknowledge a few things that I have information in here from our book, Code Check Electrical 9th, and the International Association of Electrical Inspectors. There's the George Washington chapter is based in DC, and there's a guy there named David Shapiro, who's who's the chapter president and who's a very good supporter of home inspectors. It's an excellent source of education if you're interested in that organization. Where we are right now in Virginia, as far as code adoptions, is that you are using the 2017 edition of the National Electrical Code, and next year you'll go to the 2020. So it seems like you're basically about 4 or 5 years behind on these things, which is in some ways a good thing, because as we'll see later on, there's times that they that these things don't go in a straight progression. They zig and they zag. Now, in general, the times that we see a failure of an electrical conductor are almost always at the end of that conductor, that it's at the termination, that it has its highest resistance. I'm curious if anyone here has ever seen a wire that actually had its insulation melt because it had too much current going through it for too long a period of time. I can only think of a couple of instances that I've ever seen that. Almost all the times that you see the insulation melted or the wire burned, it's near the end of the wire because it wasn't terminated to the proper tightness, to the proper torque. So starting with the 2017 NEC, they said, let's make sure that everything that's marked with a tightening torque on it be actually checked with a calibrated tool for that purpose. I don't know very many jurisdictions that enforce this on residential, but I think it's definitely um, worth taking a look at. There's a minor change in it also, coming up in the 2020 code, which is that they've given the building department approval to use other means to, such as IR testing, to determine if things are properly tightened. Excuse me. So in the code that you guys are currently using, there's a rule that basically says that you need GFCI protection if something is within 6 feet of a source of water, or in some cases, other things. And they defined that as the distance, basically the stretch string distance that a cord could reach from the edge of where water would overflow from the sink, without going through a wall or a door or a window or a doorway. And so what that addressed, it was an addition that they had put into the language that had been in the previous code, in the 2014 code. And what they were trying to address was the question of whether or not, for instance, a garbage disposer receptacle underneath the sink, did it require GFCI protection? And if we read the way that the 2014 code was written, you would say, yes, it requires GFCI protection. The way that the 2017 code was written, you could say no, because the cord would have to go through the cabinet door to reach the kitchen sink. And so in the 2020 NEC, they took the words door and doorway out of there. So they're now saying, once again, yes, the garbage disposer should be GFCI protected. Okay. This is what I mean about how it's a good thing sometimes to be a late adopter of the codes, like Virginia is. You can see which direction that they end up going. So the way that it is now is it says that if you're within 6 feet of the edge of a sink, then you have to have GFCI protection for that receptacle outlet. So here, if I have a receptacle outlet that is in the hallway, it's not even in this bathroom, but I could plug something into it and manage to reach that sink with less than 6 feet of cord. I have to be GFCI protected. So this, I think, was a little inadvertent result of their making this code change, but it's nonetheless a real one. So the bottom line for us and for you as home inspectors is that question about whether the garbage disposer required GFCI protection is resolved. Another section of the code already was saying that a receptacle for a dishwasher requires GFCI protection. And that also resulted in a rule that said that the receptacle for the dishwasher cannot be behind the dishwasher, that it has to be in the cabinet adjacent to it. Just like with all GFCIs, that the reset device has to be accessible, but it really kind of closed a loophole that used to allow the idea of the receptacle behind the dishwasher, where you couldn't really reach it unless you pulled the dishwasher out. This is not where it's going to end in terms of the expansion of requirements for GFCIs. In the 2023 code, which it'll be still some 4 or 5 years before you guys adopt that, what happens is that every receptacle in a kitchen, regardless of how near a sink or whether it's serving the countertop or whether it's serving the refrigerator, if it's in a kitchen, it's going to require GFCI protection. there's another big change in this that took place in the, I guess this is in the next code cycle for you guys, is that all of the lists of locations that we think of that require GFCIs, we've always thought of this in terms of the 120 volt appliances. And a big change now is that it also applies to the 240 volt appliances. So that is to say anything that is less than, that is 150 volts or less to ground. And a 240 volt appliance, if you measure between either of the hot conductors and ground, you're at 120 volts. So that means that they require it. So we've got a requirement already that we have GFCIs for laundry rooms. Well, we have an electric clothes dryer in that laundry room. That means that under this new code, it's going to require GFCI protection. And the only way to really do that is going to be through a circuit breaker that provides that GFCI protection. So what I'm finding interesting in all this, and especially as pertains to home inspectors, is that you can look ahead to see what the requirements are going to be, say in 2023 for GFCI protection on everything in a kitchen and everything in a laundry room and so forth, and look at an older house, and it really doesn't change what you would say anyway, I don't think, because it's just basically, that GFCIs save people's lives. That when we first introduced GFCIs into the marketplace, there were still several hundred residential electrocutions every year in this country. And since then, we've just about doubled the housing stock or more than doubled it. And the population has got tens of millions more people. And yet the number of residential electrocutions that we have has gone way down. It hasn't gone up with all this new housing, it's gone down. And the reason it's gone down, it's now usually only about 50 people a year, is because of GFCIs. So GFCIs work, and it's a good idea to have them. So as a home inspector, I think you could say that you recommend for the safety of your clients that everything in your kitchen be GFCI protected. Simple enough. And since you're not allowed to say, quote the code on it anyway, they can take your advice or they can take their chances. Okay. A change in the 2020 NEC is that all receptacles in basements require GFCI protection. That could be even in a finished basement that's got bedrooms down there, or a media room, anything else like that. And that's because as long as it's below grade, there's a possibility of moisture in the floor slab. And so it's treated the same way as any other potentially wet or damp location. Another thing they added was this catch-all of wet areas and dwelling units. This could be something that doesn't even have plumbing fixtures in it. It could be something that's just a mud room, or where the dog comes in and shakes himself off when you come back from your walk. Now, we know that when a furnace is in an attic space, or if it's in a crawl space or even a basement, any place, that it requires a receptacle to serve that piece of equipment, and that receptacle has to be on the same level and within 25 feet. It now also has to be GFCI protected. That's an additional requirement for it. That reminds me, there was a question, I think, during the break, somebody asked, since seeing that furnace reminded me, about what are the heating requirements for bathrooms. And as far as I know, there aren't any in the codes. I think it's just simply that what happens is that there's a requirement that you provide heat to habitable rooms, but a bathroom isn't considered a habitable room. So I imagine that you could have a lot of builders choosing to have heating outlets of some sort in the bathrooms, but they're not actually required, but not by code. Next, this is an interesting change here where it talks about outdoor outlets for dwelling. We got to remember what the electrical code's definition of an outlet is. It means that it's the point on the branch circuit at which the power is taken to the utilization equipment. Okay, so it doesn't necessarily mean receptacle outlets. In the case of an air conditioning unit, it's the disconnecting means is the outlet of the circuit. And then the whip to the air conditioner is part of the air conditioner, basically. So what happens is that there have been actually several electrocutions of people electrocuted by outdoor air conditioning condensers. And so they've put this in quite intentionally to say that air conditioners should be GFCI protected. So instead of having the cheap little local disconnect switch that costs the electrician $15, you have to have a panel there with a GFCI breaker in it, and it's you spend a few $100s on it. Now, there is a little bit of a problem with this, which is that the other type of system that we see a lot of these days, and maybe not as much in your climate, but we certainly see them out here, are the mini split systems. Oftentimes they're ductless mini splits where we have a wall unit on the or units in the interior and one unit on the exterior, and the interior units derive their power from the exterior unit. And oftentimes when they do that, Mitsubishi is a great example of it. What happens is Mitsubishi has power conversion equipment in their outdoor unit. It converts it to, it rectifies it to DC for the operation of the motors on the indoor fans and so forth. And so what happens is that power conversion equipment is not actually utilizing the full sine wave voltage that is available. It doesn't, because it's rectifying the circuit, it has to charge up a capacitor and go through a diode to turn it to DC. So what happens to the portion of the voltage sine wave that doesn't get used? They dump it back into the equipment grounding conductor. So when they do that, what happens is it will trip a GFCI. So because of those mini split units, what happened was that the manufacturers said, you're going to drive us out of business with this GFCI requirement. Give us some time to come up with a solution to it. And the simplest solution, of course, is to run a 4-conductor feed to that unit where you have a separate neutral to carry that small amount of current, and a separate equipment ground. And some manufacturers are already doing that, I believe. I think Mitsubishi is one of them. But what happened, though, from their appeal on this issue was that they got a temporary amendment to the electrical code that says they have until September 1st of 2026 to comply. I'm sorry, this last sentence might not be relevant to you, but it is to us out here, which is that we didn't adopt the temporary interim amendment. So technically the inspectors should be enforcing it as it is now. I imagine there's some of you that must do commercial inspections, and especially for restaurants, this is an important one, which is that that there's a lot of electric dishwashers in commercial establishments. They're oftentimes three-phase dishwashers, and basically those require GFCI protection now. So you have to add on one of these little, this is a thing made by Little Fuse called a shock block. It costs about $600. You have to add those to your dishwasher circuit and then plug your dishwasher into this. And this is an important one because there's a lot of people get shocked or electrocuted in restaurants. Basically everything in a restaurant kitchen has to be GFCI protected, including the major machinery. It might be if it's the thing for kneading the dough for pizza or bread, or it might be if it's a big mixer or whatever it is, it needs to be GFCI protected. There is an exception in kitchens for another type of receptacle. And I'm curious if you could say in the chat if any of you have ever seen one of these. I haven't seen one in the wild yet myself. But basically what this is a device where it comes with a box up above it here that is like any other recessed box you have in a ceiling, except it's large enough to contain this thing. And it has this receptacle. That's not the normal thing we think of as a receptacle outlet, but that's what it is categorized as. And then you have an appliance like a ceiling fan or a chandelier, a light fixture, that has this mating piece to it. And you stick it up there, give it a twist, and it locks in place. And so it's what's called a listed locking support and mounting receptacle. And these are exempt from requiring GFCI protection. That's why it comes up in this topic. Other commercial things, if you do commercial inspections, drinking fountains, now bottle fill stations also, because we see those quite commonly. You can substitute required drinking fountains in a workplace with bottle fill stations. Oh, I should go back to that one actually. Also, all sump pumps require GFCI protection, regardless of whether it's in residential or commercial. Okay, so this would all be in your handout. You could go through and look at it. So, just, excuse me, I'm sorry, my voice is giving out on me here. Okay, in the 2023 code, we're going to see specific statutory requirements for all of these appliances to be GFCI protected. All this is great, except for those occasions when we get back to the question of nuisance tripping. And what I'm finding in terms of the things I hear from my electrician friends is that a lot of times something like a microwave oven that's already required to be AFCI protected, if we put it on something that's also GFCI protected, that every time we use the microwave, the breaker trips, that kind of thing. I imagine you guys are probably hearing similar stories like this. Sometimes I hear it attributed to one particular manufacturer more than others, but I think that this is going to be an interesting conundrum as this all moves forward. We're about to upgrade the electrical system in our house, and the plan right now, just so you know my prejudices on things, is that I'm going to have a Siemens panel installed with the Siemens Murray breaker line in it, and have everything AFCI in terms of the breakers, but no dual function AFCI, GFCIs. I'm just going to have GFCIs on the and the first outlet of the branch circuit. So that's going to be my approach to it. So here we see Ben Franklin is, oh, he's got a fault on his toaster. There it is. Don't touch it. Oh, there he goes. So this gets back to that question of why the 2023 code says everything in a kitchen gets GFCI, because that receptacle outlet could be more than 6 feet away from that sink, but the toaster itself could be less than 6 feet. So they just said, look, we should be looking at the appliance, not the outlet. So it's the appliance itself, if it's got a fault, and toasters are a good one for that, that should be protected. So I like this for explaining the 2023 code. Sorry, that was City of Oakland. Shouldn't have been in here. Okay. This is a good one. There's a new rule coming up on bathroom branch circuits. And this is interesting. Starting with the 1996 electrical code, we required a 20 amp circuit for the bathroom receptacle outlets. Previous to that, the only times that a 20 amp circuit was required were for laundry circuits and for the small appliance circuits in the kitchen. And then they started requiring them for the bathroom receptacle outlets. Well, they made an exception to it to say that you could have, and what they said at the time was that nothing else should be on that circuit, no other outlets on that circuit other than those in the bathrooms. And this basically was a place to let your teenage daughters use their hair dryers. Okay. So they made an exception to that rule that you could have other things on that circuit if that 20 amp circuit was dedicated to just one bathroom. Okay. But now, starting in this code cycle, they're saying, you can have additional receptacles in the bathroom as long as and they can be on 15 amp circuits, as long as those aren't the required receptacle that is required to be within 3 feet of the sink. So in other words, you could have another receptacle for one of these accessories they have for toilets, where they put a receptacle outlet down low next to the toilet, and have one of these electric toilets. There's some of these fancy Japanese ones that could cost you thousands of dollars. Or you could have a receptacle outlet on the other side of the room away from your sink, and it would not have to be on that same, it would not have to be on the 20 amp circuit that's dedicated for the bathroom receptacle outlets. Another thing that changed in the 2020 code that you guys will get next year is this zone above a shower or a bathtub. Previously, our code has told us that we can't have any light switches inside our shower unless it's part of one of those manufactured showers with a touch screen in it that does a steam shower and full body massage or whatever. And that we also couldn't have any receptacle outlets directly over the footprint of a shower or tub. Well, there also has been always this prohibition, not always, for a long time, this prohibition on having either track lights or pendant lights or ceiling paddle fans directly above a shower or tub, unless it was at least 8 feet above it, or also not in the zone within 3 feet of the outside edge of it, because, you know, stepping into this tub, you could reach the chandelier or paddle fan or whatever. So this was a requirement for where you could have those kinds of lights or appliances, not in this zone. Well, now they're also saying no receptacles in that zone. So the receptacle used to, just as long as it was outside the direct footprint of the tub or shower, it was okay on this wall, but not any longer. It's got to be at least 3 feet away from it. Whoops, one other thing that will change on this when you eventually get to the 2023 code is that they extend that zone down to the floor. And they also make an exception saying you could have something that was closer than 3 feet for, say, what they refer to as a personal hygiene device, that little receptacle outlet down there by the toilet, as long as it's on the other side of the toilet from the tub. So I see a complication from this. Suppose I've got a fixed in place glass shower wall, and right next to it is my sink, and I've got my receptacle outlet there for my sink is on that wall, and that receptacle outlet is certainly more than 3 feet away from any entrance into the shower. But the way this is worded, that would still be prohibited to have it within 3 feet of the shower. It makes it very difficult in some cases. So I'm not happy with this particular code change, and I know that it's had some work done to it, and it's going to have some more now that Ryan Jackson's on the code panel for this one. So garage branch circuits. This is an interesting one. You've got a fourth place now that requires 20 amp circuits, which is it was clothes laundry rooms, kitchen small appliance circuits, bathroom receptacle outlets, and now garages. And that's because they finally recognized that a garage turns into a man cave. I've been told people sometimes park cars in them, but I couldn't imagine that myself. Our garage is, half of it is my wife's studio, the other half is my man cave. So they require this 20 amp circuit for the garages. And then in the next code cycle, they get a little pickier about it. They say that those receptacle outlets that are served by that have to be no more than 5.5 feet above the floor. So it means, oh, wait, that's not the garage door opener, is it? Because that has to be more than 5.5 feet above the floor. It's instead one for each vehicle bay that we have to have. And these other receptacles for the vehicle doors and for the lights, the lighting outlets, cannot be on the same circuit. You have to have this dedicated 20 amp circuit for your garage receptacle outlets. That's a good thing. So let's move on to AFCIs. I looked at your Virginia code to see if you guys adopt the rule for AFCIs, and it seems to me that you do. Let me know if I'm wrong on that. But I'm going to stop here before we go on and see if we have other. It's funny. Am I seeing with the chat? Oh, okay. That's what I have to do to see it. Got it. Oh, good. I'm glad somebody asked this. What about GFCI on refrigerators or freezers? Okay. Excellent question. And Skip seems to have answered it, saying that that what we have is that the quality of GFCIs is greatly improved. The likelihood of a nuisance trip is remote, and that if there's a problem, it's more likely a problem with the fridge. Jim Caton, in case any of you don't know who he is, used to be ASHI's technical committee chairman, gave me a wonderful explanation of that one time, which is that a refrigerator compressor motor has a liquid refrigerant that's inside the motor, right? You have a motor that's swimming in refrigerant. And like any motor, what will happen is that your insulation on your windings is eventually going to start failing. And the first thing that it's going to do then, as it starts failing, is it's not necessarily going to put enough, it's not going to have a low enough impedance to put a dangerous voltage onto the housing, onto the metal frame of the refrigerator, until the wiring deteriorates pretty far, at which point it will trip a GFCI. So Jim likes to say that GFCIs are the early warning device of compressor failure in refrigerators. That said, Ryan Jackson, the great electrical code instructor, he buys meat by the cow and has a huge freezer in his garage. And when he and his wife went away on vacation recently, they came home to find 200 pounds of spoiled meat because somebody had tripped the GFCI while they were gone. Must have been the home inspector. Okay, and then someone else is saying hair dryers have gone from up to 2,000 watts, and we're going to end up with tripping problems from those. Yeah, it's interesting to me that they still don't have a requirement for AFCIs for bathrooms. I wonder if that has something to do with it, but it's a good comment. Okay, for AFCIs, this is a very seldom enforced part of the code, but it's actually in your code, is that if you replace a receptacle outlet, let's just say that it's because you've had the house painted and you've had all the receptacle outlets replaced so that the house will look great for the market. You're flipping the house, and you're supposed to, if those are in a location that presently requires AFCIs, they have to have AFCI protection. So you should put in a AFCI receptacle outlet or replace the breaker with AFCIs. There's a few other instances where replacements and extensions trigger a requirement for AFCIs. One of the places that it does not trigger it is when you do a panel upgrade. Suppose that I'm going to go back here for a second. Suppose that you do a panel upgrade, and what happens is you put a new panel right next to where your old one was, and you use your old panel as a junction box and run extensions of all its branch circuits to your new panel. Fairly common situation out here. And when you do that, you're only adding to each of those branch circuits, you're only adding a little bit of wire there just to get between the two panels. And that does not trigger a requirement for AFCI protection in those circuits. So again, a panel upgrade, if it was in the same location or even if it was within 6 feet of the old one, is not going to trigger the requirement for AFCIs. AFCIs are basically required when there's new wiring or new receptacle outlets, but not necessarily when you're putting in new breakers. You have a breaker that goes bad, you don't have to replace it with an AFCI. You can replace it with an ordinary breaker. This is just different forms of AFCIs that we see. There's the receptacle type, blank face ones, and dual function. Now, we call these dual function rather than combination because the word combination got appropriated to a particular type of AFCI, which distinguishes it from what used to be before that the branch feeder AFCI. For instance, if you are replacing an ungrounded receptacle, two slot receptacle in a living room today, in theory, this is what you're supposed to replace it with, is this dual function AFCI, GFCI, that would be allowed without an equipment grounding conductor, and that would protect any appliances that you plugged into it. So I mentioned earlier that I'd like to get a Siemens panel for my house. I stole this picture off of the internet. I don't know who did this, but it's a very, to me, very fascinating photograph. First off, this is extraordinarily good workmanship. I think that they've run everything in such a way that we can really see exactly what's going on. We notice that we have actually 4 bus bars down here. Here's our neutral buses on each side, and here's our hot buses. So these neutral bus bars are for plug-on neutral AFCI or GFCI breakers. And these plug-on neutrals have been around now for, I guess, about 9 years now, 8 or 9 years that we've been seeing the plug-on neutrals, so that we no longer have to have those pigtails that come out of the AFCIs and GFCIs. All of the 3 remaining major manufacturers all make one with a plug-on neutral. I mean, basically these days, the only panel manufacturers left are Eaton, Siemens, and Square D. General Electric's just gotten out of the business. So, and they all make one like this, which is good because it makes it a lot cleaner inside the panel, not to have all those pigtails.
Douglas, can you give us a better explanation of these 2 terms, combination and dual function? Can you clarify that? There's some questions in the chat about it.
Okay, that's a great idea. Let me see what is the definition of combination. Okay, and here's someone saying they recommend AFCI on older wiring, especially cloth wrapped. First, let me answer Jim's question. He recommends AFCIs on older wiring. It's certainly not going to hurt. And when he says cloth wrapped, I mean, that's what I think of as the most dangerous wiring method ever was rag wrap Romex in the early 50s. So I agree with that one. The definition of combination. When UL created the different standards for AFCIs, they came up with different scenarios for what could cause an electrical arc. And one thing that could cause an electrical arc is to have say a nail driven through the wire, and a nail is driven through your Romex cable such that it barely touches the hot conductor and the neutral conductor, okay? But enough so that it's going to cause them to have an arc. All right, so if it's an arc between the hot and the neutral, that is something that's within the standard for a branch feeder AFCI to interrupt. And the first generation of AFCIs were just branch feeders. Then there's another type of arcing scenario you can have, which is that you could have an arc between at a break in the hot conductor or at a loose terminal. That's to say, it could be arcing at just where you plug, where it's connected to a switch or a receptacle outlet. When we upgraded the panel at our house in Santa Clara, and we put in AFCI breakers everywhere, 5 of them wouldn't hold. And in one case, I found a snap switch that was completely fried inside and that was arcing. The AFCI was doing its job, telling me you got a bad switch here and potential fire in your wall. So And that was just from a loose connection, that somebody hadn't tightened down the wire on the terminal on that switch. So that's a different kind of arc. A branch feeder AFCI cannot detect that type of arc. And then there's other types of arcs you could have to the equipment ground and so forth. So UL decided to look at the AFCIs that could detect any combination of possible arcing faults. They decided to call those combination AFCIs. So the word combination here is referring to a UL standard, okay? But that has nothing to do with the GFCI. So when we started making devices that were both AFCI and GFCI, they had to call them dual function. Does that make sense? Okay.
Douglas, I hear a lot of sudden sounds of understanding. I think there are a lot of us that have been wondering about this for a long time.
Oh, good, good, okay. So I like to think of them as first generation and second generation. And I think that if you see the first generation AFCIs, I would actually recommend replacing them with the second generation AFCIs. Replace them with the combination AFCIs, because I think that they are far more likely to pick up on the actual likely fault that you're going to have from a loose connection. Now, no AFCI, though, there is a limitation here. An AFCI will not detect a glowing connection. In other words, if your wire starts looking like it's your toaster elements, it's not going to trip on that. It's instead that intermittent spark. It looks for 8 cycles of repeated inverted wave on the voltage.
If I could jump in, just interject something really quick. I think the really great reason for recommending they get upgraded is if you plug in, let's say you got a lamp with a short internal in the lamp, a branch feeder won't pick that up. A combination will.
Yes.
You know, so if you got, and I had this happen, I went into a house, the agent said, don't worry about it. Those pesky AFCIs keep tripping. The electrician's going to come by and change them out. And I went over and looked and saw they were all combination type. And I said, the problem is almost certainly not the breakers. You've got some bad wiring. And it turned out they had a brand new light fixture, wall mounted with a short circuit internally in it. And the AFCI was keeping their newly constructed condo from burning down.
Great story. I love it. I love it. Okay. So there's times that AFCIs really do their job. I had another thing that happened with the AFCIs in my house. I mentioned that there were 5 of them that wouldn't hold. Was that on some of the circuits, what happened was that I would open up the receptacle outlets and look in the box and see that what had happened was that there was an excess length of the equipment grounding conductor, and the equipment grounding conductor was contacting the neutral terminal. And that contact on the neutral terminal is, I mean, if you did that on a GFCI, that would trip the GFCI right away, wouldn't it? Connecting the ground to the neutral. So what happened was that AFCIs used to be, it's not 100% now, but they used to also have a ground fault function to them. It just wasn't at a sensitive enough level to qualify as Class A GFCI protection. For Class A GFCI protection, the device must open the circuit if there's a leak of 6 milliamps, and 6 milliamps gets you below the threshold for even a child to have any serious damage from that degree of a fault. It's a very quick thing. I have, since I'm the presenter, I can tell one war story. Okay, I get called out on a case where these people's house is temporarily uninhabitable, and they are forced to live in their guest house while the repairs are being made. The guest house was, well, bigger than our house. And this was a big estate with a winery and so forth. And so they're living in the guest house, and they have, in this guest house, there's a room that is both the laundry room and a bathroom. So on one side of it, there's the washer dryer, and the other side, there's the water closet, and there's a big sink next to it. And the young woman who was living there said, as long as you're here, there's something I'm wondering if you could check out for me. And she takes me into this room, and she says, every time when I'm using this faucet here on the sink, and I reach up to grab for a towel over here on this towel bar, that funny outlet on the other side of the room, the button on it pops out, and I have to go over there and reset it. Okay, so think for a second what you would do if you heard that story. If your client or somebody living in the house said, told you that story, you know something's seriously wrong. So what I did was I pulled out my voltmeter, and I looked to see what was happening with it. And sure enough, that what was happening was that there was a screw in the hardware for mounting the towel bar that had gone into a piece of Romex and in the wall and was touching the hot conductor. So when she grabbed the towel bar, she was grabbing something that had 120 volts. And when she touched the faucet, she was touching something that was grounded. And that would be a full-on shock through the heart, left hand to right hand, that could be fatal, except that the GFCI was saving her life every time that she did it. So to me, that was the most convincing thing I'd ever experienced that got me just to become an evangelist for GFCIs. That, you know, I've seen somebody's life saved by this. So I think they're great.
But she wasn't even feeling it?
No, because if you have a low impedance fault through you like that, the GFCI will trip in at a maximum 1.5 cycles. In other words, a 40th of a second. So they're fast. Yeah. So no, she didn't feel it. She just noticed that the button kept popping out on that thing. So, okay. So Remy has a question that looks like Skip has answered it. It's a good one in the chat. We're going to talk some more about these new types of AFCIs as well. I'm curious, when I bring up the chat log on my screen, do you guys see it all also, or do you only see the PowerPoint show?
No, we can see it.
You see the chat log too? Okay, I'll close it back down then. All right. Okay, so here we've got.
Oh, no, we don't see it on your screen. We see it on our own screen.
Oh, okay, good. All right. So I can't.
You can leave it up.
Okay, so these are dual function AFCI, GFCI breakers. Now, because these are GFCIs, they're like any other, the GFCIs that you're used to seeing and that had a pigtail on them, where you would see 3 wires coming out of the GFCI, you'd see the neutral going in, you'd see the neutral going out, and you'd see the hot wire going out. Well, because we don't need the pigtail because of the plug-on neutral, all we see is the neutral and the hot, coming out of each breaker. Okay, so far that's normal, and these are dual function, both AFCI, GFCI. Then we look over here on this side, and we have ones that are not AFCIs, or excuse me, not GFCIs. All they are is AFCIs, and miraculously, they have no neutral wire coming out of the breaker. So this is a new technology that Siemens came up with about a year ago. That what they did basically was they said that GFCI function that is built into all of our AFCIs, it's not required by the UL standard. It's not really necessary. So let's not build it in there. Let's make an AFCI that doesn't do that. And as a result of that, what it means is that you can have an AFCI that where that branch circuit for that AFCI can connect to this common neutral bus that we see over here. That those white wires for that are the same white wires for those circuits. So here we've got 4 AFCIs where we only see one wire coming out of them, just the hot wire. Now, they do actually require that they be sitting on that plug-on neutral for this to work. But it's a very a new technology that again, Siemens was the first to arrive at it. So there's a GFCI breaker that is not an AFCI, and it does have to have a neutral coming out of it, as we see there. So it's a very interesting, very, very interesting panel. I think that this is we'll look at some more things in it that are quite up to date here. It's pretty amazing. So this is what Siemens says about their dual function and AFCI breaker, that we've got the plug-on neutral that it sits on. We've got the hot wire that comes out of it, and we've got excuse me, the hot wire that comes out of it here, and we've got the loads on it here, and we've got this. Am I making any sense here? Plug on neutral. So this sensing coil is sensing the imbalance that would be there for an AFCI or GFCI. I mean, and then we've got our conductors going out, but we've got 2 conductors going out. We've got a hot and a neutral, right? Now we look at one that's the dual function AFCI, GFCI. Now we look at the one that's just an AFCI, and we see that it's got the plug-on neutral because it needs that reference to be able to have the AFCI sensing technology work. But coming out of it, we only have a hot wire, and we can take the neutral down here from this common bus. So this cleans up the inside of our panels even more and makes it easier to wire, that we can just connect up all our neutrals on these things in advance before we've put the breakers in. And then I think there's one more of these, and that is the 2-pole combination AFCI. And that what happens with this one is that we're going to, I think there's a mistake in this thing here, because this shouldn't this be? Oh, no, it's not. Okay, so this would be like for your clothes dryer. Okay, this would be how you would do a combination AFCI for your clothes dryer, or whatever was a 240 volt appliance this way. It doesn't look like it would work for a GFCI, but because the neutral would need to go through out of the breaker. But this is just for a 2-pole AFCI. I can't think of any place that requires a 240 volt AFCI that doesn't also require GFCI though. Can you, Skip? Okay, back to this beautiful panel. Notice that we have red and black wires going to these breakers. What does it usually mean when we have a red, black, and a white in a cable? It means that we have a multi-wire branch circuit, right? And that if it's a multi-wire branch circuit, it requires a common handle tie, doesn't it? So that we can, if we trip open one part of the multi-wire branch circuit, that we also trip open the other part of it, right? But in this case, what we're seeing is no handle ties on these things. And the reason is this is a newer type of Romex cable that Southwire makes, and it's instead of having 2 hot conductors and and 1 neutral wire that they share, it's got 2 neutral wires in it. So those are not multi-wire branch circuits. Okay. Then there's another thing with this. So it's got red, black, and 2 whites and a ground in each one of those cables. Let me go back. Oops, sorry. There's another thing about this too. When you're looking at securing NM cables to your framing, the basic rule in the old days when I learned how to do it was that you could take 2 flat cables, like 2 14-2s or 2 12-2s, and put them under 1 extra long staple. Okay. But that you could, on a round cable, that would be to say a red, black, white, and ground, you could only put 1 under a staple. But what happens today is that they don't necessarily make round multi-conductor cable anymore. So if you buy something that was that had a black, a red, and a white, and a ground in it, it would be flat. And so staples used to be that you would choose your staples based on how long they were. Now you have to choose your staples based on how wide they are. So it's and I'm sure that this is something that a lot of small electricians will get wrong. Although Milwaukee does make a nice tool for cable staples. Anyway, battery powered. So my last question about this panel that I'd really like is I'd really love to know who did it so that I could hire him to rewire my panel. It's just such a beautiful piece of work. All right. A lot of changes on the required receptacle outlets in kitchens. And again, you guys are lucky that this is something that's not necessarily in your area yet. Oh, okay. Okay, his laptop battery went. Oh, he's using his phone. Okay, good. Just reading the chat. Okay, it used to be that suppose we had a kitchen island and you wanted to have a receptacle outlet for that island. Until about 1993, the code didn't really say anything about islands or peninsulas. Then they started to give us requirements for them. And then they required, and this is what your code is today, that we have at least 1 receptacle outlet for each island countertop space. well, what's a separate countertop space if it's all the same island? Well, basically what they're saying is, suppose I've got an island that has a cooktop in it, and there's a counter space on each side of the cooktop. Then those count as separate spaces, and each one would require a receptacle outlet. Now, suppose that it wasn't a range maybe in this island, but it was just a sink, like a bar sink type thing. And the space between the back of the sink and the end of the island was 12 inches or more. Well, they would say, well, you can carry that cord around that sink, so you only need one receptacle outlet because it's one counter space. Okay, so that was how they defined it. Okay, and that was what you had up until now, up until the upcoming code that you're going to have. They changed all that. They no longer have any definition of what constitutes a separate counter space. What they say is that you have to have at least one receptacle within 2 feet of the outer end of a peninsula, and that for that island or peninsula, you need a receptacle for the first 18 square feet of it, and then another receptacle for each additional 9 square feet or a fraction thereof. So except for that receptacle at the end, they could be wherever you wanted them to be. They could be wherever the designer thought was going to be the right place for them. So I think this is a lot of stuff to absorb. We've got to look at a picture of it, of what they're talking about here. So this is the upcoming code. And what it's saying is that this island here, because it's 7 feet by 4 feet, it's 28 feet. So I need one for my first 18 square feet, and I need one for my next 9 square feet. That gets me up to 27. And oops, I've got an extra square foot there, so I have to have a third receptacle outlet. So I'm going to have 3 receptacle outlets for that countertop. Okay. So that's quite a lot of receptacle outlets there. And also, if this is a peninsula, we're looking at that, and we know we're going to have one within 2 feet of the end of it. But the way we're going to measure that peninsula is we're going to measure it starting from here. So everything in red is part of the dimension of that peninsula. In this case, we've got one that's 16 feet. So we only need one receptacle outlet for it. In the 2017 code, it could be the one on the wall. In the 2020 code, you'd have to also have one within 2 feet of the end of it here. So far making some sense. Okay. And of course, they say perpendicular wall. I don't think that little peninsula is perpendicular to anything. It looks pretty much at a 45-degree angle. What do we call it? I would still treat it the same way, but it's interesting how they've done this. Now, notice also that this receptacle on the end here is not supposed to be more than 12 inches below the countertop if it's considered to be serving the countertop. And if there's an overhang, it can't be more than 6 inches over the top of it. Okay, so the other thing that changes, that's a really big change, is that they say you could have well, actually, first let's look at what's not a change. What's not a change is you could have an outlet that was above the countertop. Like, say we had a set of kitchen cabinets that came down above your countertop, and you could put the receptacle outlets in the underside of those upper cabinets, as long as they weren't more than 20 inches above the countertop. Or we could have them as those pop-up receptacles that actually sit in the countertop itself, and you press them and they pop up and you can plug something in. So those aren't changes, but the new one that's a big change is it can be below the countertop for anything, whether it's an island or whether it's just your regular countertop. And you've got this maximum of 12 inches below and maximum overhang of 6 inches. So this detail here of saying not more than 12 inches below, not more than 6 inches of overhang, you could do that not just for islands or peninsulas, you could do that for anything in your countertops. Now, the previous code, the one you're on now, said you could only do it for islands and peninsulas, or they also said, for their words, construction for the physically impaired. In other words, they're meaning wheelchair access, okay? Which is, I gotta say, that's completely stupid and always has been, because the accessibility requirements set reach range distances on reaching over the top of the counter to the wall that would be enforceable under most ADA regulations, and that this would be the last kind of receptacle anybody would actually want to use. Anybody in a chair. So this was the big change, that we've got this being allowed for everybody. And now we'll continue on, see what else they did to it. It used to be that these were separate, that if there was another space off to the right there, that would be separate space if that was less than 12 inches. Okay. So what's going to happen next? Once you get to the 2023 code, everything I just told you goes away. Everything. That you're no longer required to have any receptacle outlets at all at an island or a peninsula. And if there aren't any, then you do have to put in the infrastructure for them. You could run an empty conduit to the island, or you could run a cable and underneath in there and have it terminate in a box that's got a cover on it. So no requirement for island and peninsula receptacles. And this whole thing of where I just got through telling you that this next code cycle says you can have them below the countertop surface anywhere. Well, they're not exactly prohibited. They are, what's a better way of saying this? They are, I'm about to edit something on the fly here, always a bad idea. They are, there we go. They're not required, okay. So, and the reason why I have to say that they're not required rather than that they're prohibited is that the section that this all comes from in the electrical code in 21052C is, the title of the section is required receptacle outlets. It doesn't say where receptacle outlets are prohibited. Now, I have a personal pet peeve, and I put in for a code change on this several times. I'm going to do it again for the 2026 code to say that, and I'm sure some of you have seen this, where you've got your range with your countertop spaces on each side of it, and it's up against a wall, and somebody puts a receptacle outlet on the wall right behind the range. So the only way you can ever reach the plug for that, to plug something into it, it has to go across a burner on the stove. I think that's a pretty silly place to put receptacle outlets, and I keep trying to get it outlawed. But the problem is that this section of the code talks about where they're required, not where they're prohibited. Okay. So I'm going to have to go to a whole different code making panel to try to get that one prohibited. It's going to be something in Article 406, not Article 210. Anyway, so that I've been tilting at that windmill for about 15 years. We don't require them there. So what do we do? Why are they making these changes? Why has the electrical code flip-flopped? Okay, well, we got to go back and look at what the hazard is. If you don't have enough receptacles, what are people going to do? They're going to use extension cords, okay? If you do have enough receptacles, then what's going to happen? You're going to have people reaching up and pulling the frying pan full of bacon grease onto the little kid's head. So that's the hazard. And so you've got a hazard of not having enough receptacles. You've got a hazard if you do have receptacles on the side there. So, and then I'm looking at the chat. Remy, don't let me get away without answering your question. I don't want to answer it right now. I see that Jim has answered it, and I like both Jim's answers, but I want to go back to it because there's another topic with that. Okay, so I've got a little summary here. Receptacles in islands and peninsulas. You guys are in the left-hand column. One per countertop space, which they're no longer going to define next year. And it could be above or a listed surface assembly or up to 12 inches below. Next year, more receptacles, okay? One for the first 18 square feet, one for each additional 9 square feet, okay. 2023, you don't have to have any. And if you do have them, they have to be above or a listed surface assembly, okay? So how did all this come about? Again, like I said, there's two hazards that they're trying to weigh which one counts the most. And so for you as a home inspector, I think that the thing here is this is where, especially if you've got the purchaser of a house with you, educate them on what's going on here. And again, you're not tied to whatever code that house was built to. So the hazards are the hazards. They don't care what's written in a book. Okay, so the Consumer Product Safety Commission has compiled a lot of reports on this issue, and they've said that they've documented 9,700 burns, injuries as a result of that kid pulling the frying pan onto themselves, and even of people in wheelchairs who died from the hot contents getting pulled onto them when they just drove their chair past it and got snagged on it. I remember once about 25 years ago, I was teaching a class, and there was a guy in the class that had this really interesting birthmark and on one side of his face. And when I got to this slide, he told us the story, and it wasn't a birthmark. It was a frying pan full of bacon grease. And he was a little kid. He pulled it onto his face, and he's got a scar there forever. There is also, and this would be a good reason for you to download the PDF for this. There is an excellent video on this on YouTube on Ryan Jackson's channel. So there's two people that I think that you really should be looking at for code education online. One is Glenn Matheson with buildingcodecollege.com, and the other is for electrical is Ryan Jackson. And if you just go on YouTube and search for Ryan Jackson Electrical, you'll come up with dozens of videos that he's made that are really, really good. And if you look at this particular one, you'll see him discussing in more detail this whole story of how the electrical code got to this place of going, wait a minute, we don't want these receptacle outlets down low. So it's an excellent video. He also sits on a couple of the code making panels, and he's a professional electrical code instructor now. He's really good. So here I'm just summarizing where receptacle outlets are going to be required in your next code. Okay, it's saying your refrigerator can be on its own circuit. Other appliances in there can be on their own circuit. Of course, your dishwasher, your garbage disposer, etc. One of the other changes that you had recently was that the required receptacle in a wall space, if we're going to have a built-in cabinet here, does not require that there be a receptacle there before you put that built-in cabinet in, and only requires it if that cabinet has a countertop, in which case it would require receptacles above that countertop. And that, I should add, really only applies if that countertop is less than 5 feet above the finished floor as well. Okay, so this is an illustration from that book that Skip just got 300 copies of. Okay. So of course, no face-up receptacles in countertops or work surfaces. You're supposed to use the listed pop-up receptacles. And these cost a couple $100, but they are tested by UL for water resistance. There's actually 2 standards for them. There's one for what they call countertops, and there's one for work surfaces. The difference between the 2 is just the amount of water that they test them with. But you press that thing back down and it makes a watertight seal to that little gasket. Okay. So that's it for receptacles in kitchens. Now we've got a couple of big topics still ahead of us. So we also have a lightweight one here. Hey
Douglas, before you move on from electrical, you were talking about the face-up receptacles. How about wall receptacles in floors and mantles, fireplace mantles?
Oh, okay, yeah. In a floor, it's not the receptacle that has to be listed for the floor. It's the box that holds the receptacle. And there are 2 basic types of them, plastic and brass. If you look in look at the floor in the airport the next time you're there, and you'd see in a lot of older airports, you'll see these brass cover plates over receptacle outlets. A lot of times it's got a screw-on cover to protect the actual receptacle, be a single receptacle. They've gotten away from using those brass ones because, of course, people steal the little screw-out cover to salvage the brass. They make them mostly out of plastic now. They make adjustable ones that you can adjust to work with whatever height your finished floor material is. And the UL standard for floor receptacles is that they run a carpet shampooer over it, and that there has to be no water that reaches the receptacle. Okay, so that's for floors. Now for mantles, I wouldn't necessarily consider a mantle to be a countertop or work surface. I'm just about at the point of saying I couldn't get too worried about it, and from a code standpoint. And then I'm realizing, of course, what would my wife do on that? She would put a vase full of flowers and water right up there. But anyway, Um, the I think it would go back from a code enforcement standpoint to how you defined that mantle. You know, did you define it as a countertop or work surface? And I would say probably not. I'm going to ask a couple of rhetorical questions here. And actually, before we get going, I want to address the other thing that came up in the chat, and that has to do with torquing on terminals. I think that I started this talk on electrical mentioning how important that is. And I know that when I was the senior electrical inspector for our building jurisdiction, I trained all of our inspectors and had a separate class that I did on how to observe torque inspections and what we required of different in different situations. That it was very important to us. But the thing about retorquing something is that it can do more harm than good, because when something is set to its proper torque, it will have some relaxation from the stranding of the conductors and so forth, moving just enough into the interstitial spaces that it wouldn't give you the same reading again, say the next day even. And so if you retorque something, it should not be to the manufacturer's setting. It should be to 90% of the manufacturer's setting, which is something that you really only get by looking at the UL standard. The other thing with it is, you know, we used to use in data centers. I plan checked a lot of data centers, and we would accept the as part of the commissioning when they did those, when they build a data center, they typically go through and they do infrared testing on every terminal inside the entire place. And this could be thousands, but it's at least hundreds every time. And we would accept the IR log in lieu of observing torque testing, because IR is more accurate. But in terms of IR in a home inspector capacity, what happens is that you can use IR to look at a breaker and get a true positive saying this is too hot, but you can't use it to detect you can get a false negative, because it all depends on knowing the exact load. And so I think that IR has a lot of places, but it's got to be very careful about using it around electrical or for that purpose. Like I say, you can oftentimes confirm something's wrong here, but you pulled out this tool and people have watched you use it, and you haven't found something wrong doesn't mean there isn't something wrong. That make any sense? Okay. So now to my rhetorical questions. Do you guys take the cover off of electrical panels? Somebody speak up.
Yes.
Yes, somebody said yes. Would you do that on a commercial inspection?
Yes. No.
No, good. Okay, no was the correct answer I was looking for. All right, but you do in residential. So my next stupid question, if you take off these panel covers, do you turn off the main breaker first?
No.
I would say probably not, huh? So you're taking off this cover and you're going to expose yourself to the live parts inside. Is that true? Actually, if you did turn off the main breaker, would that lessen your chances of danger?
There's still voltage at the main.
There's still likely to be live parts inside there, aren't there? Okay, so what do we have? We have a requirement that came out in the code that you're already using that says, actually, is this in your code? Yeah, it is. It is. That says that you'll place barriers in your service equipment so that the uninsulated live parts there are not exposed to being contacted. So in other words, if this is my main breaker, I've got those two supply side feeds coming in at the top. I put these little boots on it, and if I did shut off the main breaker before I took off that panel cover, there wouldn't be anything I could get electrocuted on in there, would there? I could inspect this using the Braille system. Okay, so that rule requiring those barriers was up there in the article on panels in 408. And it was consistent with UL 67 and so forth, but there was an exception for it. And the exception gets to my next rhetorical question: how many disconnects are you allowed at the main service? Okay, pretty standard question that is probably on every home inspector exam, right? And
6, obviously.
6, okay, thank you. Thank you for participating. Okay, so that used to be the rule. But what is happening now is we're going to see that in going forward from 2020, that each service enclosure is only allowed 1 disconnect, period. So this old rule of you could have up to 6 disconnects in a single enclosure has gone away. Okay. And at this point, nobody could actually even manufacture something like that and get it with a UL listing on it. So the whole idea of first those barriers and now saying let's no longer have the exception for the 2 to 6 disconnects in there is basically so that if you did shut off that main breaker before you opened it up, that you could not get electrocuted. Okay.
Now the 6 disconnects in one service.
1 enclosure.
Yeah, but still 6 in the service, 1 per enclosure, correct?
Got it. You've got it exactly right. That is the new rule. So suppose I had this is a 3-unit building. Suppose I had this service coming down to do I have a picture of one here of a hot gutter or something like that? What I don't. Okay. And I had 3 separate enclosures, each of which was a main breaker for its unit. That would all still be service equipment. I could have up to 6 disconnects to shut off all the power to the building, but I could only have 1 disconnect per enclosure. And so in this particular instance, this is a very common type of panel that we've seen. I'm used to seeing lots and lots of these, and they're no longer allowed unless there is a single main disconnect upstream of this. And the reason being that you take that cover off, and I'm only working on this one on the bottom. I'm adding a 4th breaker and adding a 4th meter here, but I'm exposed to live parts up above here once I took this cover off. So that isn't any longer allowed. The same issue with commercial equipment. This is commercial service equipment. If there's a main breaker ahead of all this, you could have it, but otherwise no. You'd have to have a barrier between each of these compartments and everything covered so that there were no live parts when you took that cover off.
And what year was that?
That is in your next electrical code cycle. It's in the 2020 NEC, which you won't be enforcing until January. Okay.
Thank you.
So this is a prelude to it, but it's also, it also really gets me thinking about what is the purpose of this new rule? The purpose of this rule is, I think that once we get to, look ahead, what are people going to look back on the 2020s when they're the home inspectors of 2050? They're going to go, oh, it's one of those old panels with, you could put 6 disconnects in it. It's terrible. You could get electrocuted, even if you shut off the power on this, because it's still got a live bus bar inside. Can you believe it that they used to make things like that? That's what they're going to be thinking 20, 30 years from now when they look at the stuff that we now see every day. So, so basically, what that other person just said, the 2 to 6 disconnecting means are permitted, but as long as they're in separate enclosures and there's a separate service disconnect in each enclosure, and that this also applies to commercial. So it's a big deal. I think this, of all the changes that there are in the upcoming code cycle, I think this is the biggest one. Okay. But just in case that wasn't enough, there's one more. A lot of times I've seen houses in Virginia where I've seen just the electric meter on the outside, and the first place that the actual service disconnect was in the basement or in the inside of the building. That's no longer allowed, or not going to be any longer allowed. Instead, what's going to happen is that there must be an emergency disconnect on the exterior of the building for 1 and 2 family dwellings. Now, that emergency disconnect could consist of the service equipment with a breaker, that's in a type 3R enclosure that can be out there in the snow, or it can be a shunt trip, or it could be a meter disconnect, but that's a very unlikely scenario. Meter disconnect really is just another variation of the term for service disconnect. So the other thing is that emergency disconnect has to be capable of actually working. It has to be rated for being opened under load, rated for the available fault current, and so forth. And that it's got to be marked as the emergency disconnect. Now, where this gets to be a little bit weird is when we look at houses today that have photovoltaic systems, that have battery backup systems, that have other energy sources. You have to have an emergency disconnect on the exterior for all of those. And you have to have a map basically at your emergency disconnect saying, by the way, you need to also go shut off this, and here's where they are. It has to be a permanent plaque for that. So the whole purpose of this is to protect firefighters so that when they show up, they can shut the power off. Okay, so each of these other related sections in the code also has an amendment to it to coordinate with this. Okay, now we get to the third most important big change in the code, is that every electrical service now requires surge protection. And this applies whenever you replace a piece of service equipment too. It's not just new houses, it's applicable when it's replaced. So what is this surge protective device all about? Okay, the idea of the surge protector is basically to help protect the electronic equipment that is both in your circuit breakers and that is in your house that you're using, that your computers, your TV sets, everything has got electronics in it these days. And what happens, there are several changes to the code on this, that it used to be that we had this distinction. We used to have a separate article in Article 250 about it. Now there's one in Article, I think new Article 242 or something. Over voltage protection is what they call it. There's 2 types. There's surge suppressors, that are for high voltages, and there's surge protection that are for low voltages. That's to say 1,000 volts or less. Now, why does this matter in a house? Going back to what we talked about this morning, about that indirect lightning strike, the one that wasn't your house that blew up your CSST, it was the one on the house across the street from you that still blew up your CSST. So when you have an indirect lightning strike, what will happen as the voltage on your system rises, and it could rise through your neutral conductor, basically on this indirect lightning strike, that this surge protection will keep that from, it will shunt it to ground and keep this from damaging the rest of your electronics that are downstream of where this device is connected. So every house now gets surge protection, and they give us these different categories of surge protectors. You know, the type 1 or 2 is what you're required to have. Type 3 on the load side of a branch circuit breaker, that's a different, trying to think of an example. Outlet strip would be one. My computer is plugged into a type 3 surge protector. And then type 4 is something that's actually built into a piece of utilization equipment. So, so this is, I think, another huge change coming up, that we're going to require this, and that it's required on every service upgrade as well. Okay. No, you guys don't care about that one. Do you guys use concrete encased electrodes out there in Virginia?
Yes, lots of times.
Yeah.
Oh, good. Okay. Well, I guess we should talk about that one then. Good. Do I have oh, good. I have a good picture of it here. Okay. So one of the problems well, first off, let me go back a little bit to where this all comes from. These are commonly referred to as UFER grounds. And when I first heard that term, I thought, oh, that must stand for underground ferrous rod. No? Well, it turns out it's actually the guy's name. His name was Herbert UFER. He was an engineer for UL. In World War II, he was trying to find a way to safely protect Quonset huts that were full of ammunition, to protect them from lightning strikes, particularly when they were located in areas like New Mexico that had a very low groundwater table and so forth. And he came up with this idea of using the steel that was in the footing as the grounding electrode, and began testing it and continued to test it, and up through the 50s and 60s, along with Creighton Schwann and a few other people. And they eventually got this into the National Electrical Code just the year after UFER himself passed away in 1970. And it was used primarily on the West Coast before it got east of the Rockies. But it's in the electrical code, and it says that if it's available during construction, you have to use it. So there's a lot of misconceptions about it. A lot of people think it means you have to add a piece of steel to your foundation for this, but it's basically just you have to connect to the steel that's already going to be in there. Okay. And where you make that connection has to be in a location that's protected from corrosion. I know when they first started doing these in Florida, people were sometimes just running a piece of rebar out the side of the foundation. Well, that's going to rust. That's not going to do any good. So it has to be where it's protected from corrosion. Now, you could run your number 4 copper wire inside and attach the clamp inside the foundation, or it could be, as we're seeing it here, brought up through the in a protected location. Also, it has to be at least 20 feet continuous or contiguous of steel, but that doesn't mean it has to be one piece. It could have several pieces tied together to form overall the 20-foot length. So there's one small change in your previous code, in the code cycle you're on, is to put it in a location protected from corrosion. Another change is that you can't use this to interconnect other electrodes. In other words, I couldn't decide, gee, I'm going to just connect my water to my UFER and my ground rod to my UFER and then go back to my service. You can use the water for that within 5 feet of the building, but you can't use the UFER for that. So that's why everything here you see is connecting at the water pipe here. Okay, let me check the chat here. Oh, I see the back to the external disconnects. The problem is mischievous or worse persons who would shut off power. And somebody said, Sean said, yeah, people put locks on these. I had a lot of discussions with our fire department about this, and they are fine with people locking the emergency disconnect because every fireman carries a universal key. Okay, it's on every fire truck. Is a universal key that will cut open any padlock. Okay. So
10 minutes.
10 minutes. Okay, we're gonna skip a lot of the last part on the photovoltaics here. Okay, but that's okay. All right. So this is an interesting clarification here, something I always thought was true to begin with, but it's that suppose I've got this sub panel that we're looking at here, and I've got my separate neutral bar here and my separate equipment ground over here that is secured to the panel. Okay, but suppose I want to add another equipment ground bar here. Do I have to run a wire between these two equipment ground bars to make them continuous? Well, they answered it for us this time. They said, no, you don't have to. It's only the equipment ground. And so it is okay for the enclosure to electrically connect it, all right? Now, suppose this was the service panel. And this had a main breaker and all this. You got to bear with me here and visualize this. Suppose it had a main breaker and that was a neutral bar over there. The answer would be no. You can't let the enclosure be part of the path for the neutral, but you can for the equipment ground. Now, there's one more little thing I want to add. Probably you guys don't go through more than 2 or 3 days before seeing a sub panel where somebody has the grounds and neutrals connected together. And a lot of times it's because when they purchased that sub panel, it didn't come with an equipment ground bar. It's something you have to actually buy and spend another $5 on in order to get it in there. So there could be, if somebody is going to add an equipment ground bar, there's 2 possible scenarios. One is that there are already pre-tapped holes in the panel that will accept the threads on the equipment ground bar that you have purchased for that brand of panel. Okay, that's one possibility. The second possibility is you have to tap it yourself. Now, you can't use a sheet metal screw to tap it. That's not allowed. But suppose you pull out and you tap it, and now you're putting in something in a place that it wasn't listed to be. You have to scrape the paint off the panel first. Okay. If it was through the holes that were part of the listed equipment of the panel, you don't have to scrape the paint. But otherwise, scrape the paint. Make sure that thing sits down there on something that's really metal to metal contact with no paint in between. Okay. Oh, this is a good one. Very common problem is to see large conductors. Let's go back and look at that panel and see if they did it. Oh, they do. They've got a bushing on it. See how it's got this rounded bushing here? That's required when the conductors are number 4 or larger. And it used to say in the old days that it had to be a smoothly rounded bushing. Then it said it had to be a smoothly rounded insulating bushing. Now they took the word insulating back out. So we can do it with something like this old picture. But where this is most commonly done wrong is with PVC. People seem to think that a PVC fitting, because it's insulating, doesn't mean that it needs a bushing, but it does. And it's because those sharp edges on those PVC fittings can cut the insulation on a conductor. And that's another thing too, is that conductors don't stay in place where you put them inside a panel, even, especially if it's aluminum. They're going to have a longitudinal expansion and contraction. If it's copper, they might have movement from magnetic fields when you turn something on and off. It's like when you could be in a big commercial building, and sometimes when they shut off a motor, you actually hear the conductors bounce inside the conduit. But anyway, it requires it for PVC. Okay. This is a picture from a commercial application, but I put it in here because we're gonna expand this into a residential one here. Suppose I have my my conduit going in here to my light inside this walk-in cooler. Well, what's going to happen is that my air inside the walk-in cooler is going to be cold and dry, and my air in the conduit up here is going to be hot and wet. And so what's going to happen is it's going to condense moisture inside that walk-in cooler and rust out my light fixture. Anybody that's ever worked in a restaurant has seen this. So what they have to do is seal that conduit where it goes between those two temperature zones. The reason I'm bringing this up is because it also applies when a conduit goes from the inside of a building to the outside of a building. And you might have that happening with, say, for instance, somebody powering up an air conditioner by running a piece of conduit through the wall from the interior to the exterior. It should have a seal off fitting at that transition. Okay. The other thing that you'll see that you'll like in the next code cycle is they brought back some of our old familiar tables. And they've also expanded this requirement to allow energy monitoring equipment in panels. This one, this is a knob and tube thing. They changed the rule on this to say, it used to be that if you used a plastic box, you had to enter your knob and tube conductors through separate holes. Now they're saying you do that for steel boxes as well. I don't like this. We're going to skip this. Boxes at paddle fans. So that's really a new construction one. Even though we have this requirement to secure NM cable within 12 inches of a box, there previously was nothing to stop you from having an, looping this all over the world before it goes to the box, as long as the staple was within 12 inches. Now they're saying, no, that wire can't be more than 18 inches between them. And I think this isn't really a change. And I think Virginia concurs exactly with those two, from what I read in your code. This is an interesting one. That intermediate metal conduit finally gets its day. Rigid conduit and intermediate conduit aren't made out of the same kind of steel. Intermediate conduit is tougher. It's a better steel than what they use in rigid, and so it's just not as thick. And so a lot of people seem to think that rigid is necessary for, say, support of a service mast or in other applications where it's being installed for protection of the conductors or something like that. And what this is saying is that that basically that you could also use intermediate for that purpose. And I expect that there'll be some more cleanup on this language too once, because now Ryan Jackson's on that code making it. He represents the Steel Tubing Institute now to the codes. Last one, this one just I'm really glad we got to talk about this one. Aluminum wire is coming back. Okay. So the old days, the problems with aluminum wire when it was first introduced in the 1960s, the Kaiser K-Flex and other things, was that it was really not a wiring grade of aluminum. It was a utility grade of aluminum that they would use in the steel reinforced aluminum overhead conductors. And so it had no business being in an M cable. And we all know this old stories of how it's been, you know, there's different kinds of splicing devices you use for it and this, that, and the other. But for a brief time in the 1970s, there was this stuff called copper clad aluminum. And so it was copper on the outside with aluminum on the inside. And it has come back now. And it is going to be widely available, and it's going to be very easy to miss this as a home inspector, because what happens is that the same color of cable is going to match for the equivalent ampacity of copper. So in other words, a 12 gauge aluminum wire is only rated for 15 amps, but the new copper clad aluminum 12 gauge is going to be in a cable with a white jacket. And the new copper clad aluminum 10 gauge that's rated for 25 amps, which we could then put on a 20 amp breaker, it's going to be orange, just like your current number 12 orange copper wire. So there's, excuse me, did I say orange? I should have said yellow. It's right in the screen in front of me. What's the matter with me? Okay, so in other words, it's going to still be that you're going to see white cable is for 15 amp breaker, or a yellow cable is for the 20 amp breaker, orange cable is for the 30 amp breaker. That's still going to be the same, but it's just that the only way that you're going to know that it's copper clad aluminum is if you're lucky enough to see the writing on the cable, or if you are lucky enough to be able to see the termination of it, like say where the neutral has been cut going into the panel. And so the ampacity of it is the same as it is for other aluminum wire, but the connections of it is, because it's copper on the outside, it's allowed to be installed with something that is rated for copper only. So that's a good thing. So
we're about to wrap it up, Douglas.
just about one last thing here on aluminum, and that is that we're also going to see 14 gauge copper clad aluminum wire. This is in the 2023 code. And we're going to see 10 amp circuit breakers for lighting. And that's because the lighting loads in a house now with LEDs are so low that they can do this. Now, I know the one person who's really upset about this is Mike Twitty. He thinks that he just foresees this becoming the, there's just too many ways for things to go wrong. And Mike would know, he gets to see them. But I just want you guys to know that it's on the table as well. It'll be a little while before you run into this one and houses there. So I think that we've run out of time. I was going to entertain you with some other little stuff here, but I think that Hollis, should we be wrapping it up here?
Yeah, I have a concert to go to.
Okay. Where can I get the updated code book for the Virginia Code? Question in the chat. On our, if you get the handout for this, I have the link for it is inside one of the slides on that handout, right near the beginning. Okay. but basically just do a Google search for Virginia residential code, and you'll find it. And Skip also had answered that in here as iccsafe.org.